Hello, we will be starting soon. Couple of minutes. Hello, people. Thank you for coming. I want to welcome you to our symposium, Student Energy's peak event of the year. Would like to thank everyone for coming. Also, the ones who are attending online. I want to disclose that this event is streamed online, right? And we will be starting with an opening statement by our chair, Twarita. Please welcome her.
Good afternoon, everyone, and welcome to the Student Energy Symposium. We're delighted to have you here to discuss one of the most pressing topics at the moment, the impacts on global events on energy and energy transition. Student Energy is a global youth-led organization that aims to empower the next generation of leaders to accelerate the transition to sustainable energy future. The organization operates through a network of student-led chapters across the world in different universities, providing opportunities for young people to develop their skills, network, and knowledge in the energy sector. Student Energy Groningen is one of these chapters, and we're proud to present our symposium today. Organizing a symposium of this scale requires a great deal of time, effort, and coordination. The team at Student Energy Groningen has worked tirelessly to bring together a group of speakers from various different backgrounds and knowledge to share their insights on the impact of global events. From securing speakers to organizing logistics, the team has put in a tremendous amount of work to make this event a success. The world is currently facing a range of global events that have significant impact on energy and energy transition. From geopolitical crisis to climate change, These events have challenged the world's policymakers, energy experts, scientists, and society as a whole to rethink and reimagine energy transition, and also how we produce, distribute, and consume energy. Today, our speakers will explore some of the most pressing issues, as mentioned before, and their potential risks and opportunity in terms of energy transition. Our speakers, Dr. Professor Kalantar, Mr. Till Eichler, and Dr. Professor Fai, will be talking about nuclear energy and their risks with regards to government policies, political choices in fossil energy crisis, and accelerating the energy transition and industrial transformation. I would also like to mention, as mentioned before, that our symposium is available for live stream, and I would like to warmly welcome all our viewers online. We're proud to share our message with such a broad and global audience and contribute to the conversation on sustainable energy practices. In addition to our speakers, we're also have giving an opportunity for networking with everybody in the audience member as well as our speakers. So once the speeches are over, we invite everyone to join us for drinks, bottle, and networking outside of this auditorium. I would like to take this opportunity to express my warmest gratitude for my organizing team, Anna, Emilios, Eva, Kheri, Mintu, Nicholas, Vivian. We could not have done this if not together. I would also like to thank Stichting OTP for providing us with these reusable wristbands, which we would like if you could return it later so we can maintain the sustainability of it. I would like to thank the board of Atmos for providing us with this opportunity, Piper and Vaughn from the Global Student Energy team, and Eliza Gianelli, Alexa Dvorska, and Christos Lazaridis for helping us organize some of the speakers. With that being said, thank you, and let's get this started.
Thank you, Farida, for opening. I would like to introduce our first speaker, Professor Kalantar. He's an expert in nuclear physics, fuels, and energy. And he's also the head of the ESRIG. He's gonna introduce his topic, the potential risks of nuclear energy put in perspective and government policies. Please welcome Professor Kalantar.
Thank you. So I guess I'm connected, right? This is working, right? Everybody hears me? Very good. Do you have a remote?
Yes, we do. Yeah.
I don't like to stand next to this. So put it on the slideshow. So let me also thank you guys for inviting me. It's a pleasure to give this sort of speech or talk or whatever you want to call it to this audience, of course. My expertise has been nuclear physics in the past, and recently, in the past few years, I've got interested in nuclear energy. And based on my experience in nuclear physics, of course, I'm now building these activities in our group to see what we can do and what we basically can mean for the energy transition for the future. But I was asked basically to put things in perspective as far as is global impact, the impact of global phenomena is concerned, or global happenings, whatever happens, what is the impact on the energy transition? This by itself takes actually a few lectures, because there are so many things happening around the world, just to name the last one, which is the invasion of Russia of Ukraine, which then basically offsets anything that you have been planning very roughly and then very also harshly. So effects of things are like that also, which are prompt, but there are also things which are sort of continuous, like the global warming, as you all know. So I'm trying to put this in perspective. Can we turn these lights off? I guess it would be nicer than for the transparencies. So I guess I don't need to even discuss these issues. I can do it also. Oh, okay. Yes, looks a bit better. Yes. I don't need to convince this audience, of course, about the global warming and the effect that it basically has on life. But I just wanted to show you this picture because this picture shows you basically the temperature rise, if you like, from 1880 to basically a couple of years ago. And if you look at it carefully also, you see that the sort of normalization line, which is 0, is around 1960s, basically. So that's a reference point that we have. Before that, you actually see it is even below that. So if you go and start the reference before that, of course, the temperature is even more than 1 degrees, which we have at this moment. But at this very moment, you are talking about 1 degrees, and you have all heard about this limit that we want to put on the 1.5 degrees and not more, right? So you see the trend is clear. Every scientist sees this, usually panics, right? I mean, says that there's a problem, we have to do something. The CO2 emission, these are basically correlations that we see. When we have a rise in the temperature, of course, there must be something else which is driving that. So what is the driving force? Many parameters, of course, come in, but this is one of the parameters that I'm presenting here, and that's the annual CO2 emissions. Again, this is plotted from 1750 all the way to today. Now, you can see, of course, just before the Industrial Revolution, there was nothing. So nature was very happy with us, right? As soon as, of course, Industrial Revolution happened, you can just see that the increase, the trend is very clear. It becomes exponential. There are here dips, as you can see here at times. They're all explainable. And the last one, of course, is because of this last dip, Corona, right? So again, something happens, and then you see immediately the effect on the things that you are studying, CO2 emission, energy consumption, whatever it is. Direct effect, okay? And this just continues. You can just do this experiment time and time again, and you will see the same results. Of course, with people and with societies, we cannot do experiments. We cannot say, so let's just turn off the economy just for a year, just to see what happens. But this should be then the role of the scientists to predict, to tell you basically, to tell people basically what can happen if you do this or what happens if you do that. Okay, so these two are just the trends, and it just shows you the problem. The problem is basically the energy consumption that we have around the world, and it's just increasing, okay? There is no stopping of people to say, look, enough is enough, we want to do less. Actually, it's just increasing, okay? There is this increasing climate problems, which is correlated to the first problem. Of course, you increase the energy consumption, you get more problems. And we see that also, we can measure it. And then the other problem is the decreasing energy reserves. The energy reserves, of course, we are talking about oil. Of course, people know that there is a limited, basically, amount of resources that we have in nature. Whether you're talking about oil, even uranium, there is a limited amount. Everything that we talk about, there is a limited amount. Even on the soil, I mean, we are talking about the sun panels, basically. Also on the silicon, you could argue that there could be a limit on that. So these are the problems. And the solution, I don't know what the solution is. Because the first problem I told you is the increasing of the energy, right, that we have. And this is not a scientific problem. This is not a technical problem. It's a societal problem, right? People are hard to get to the point where they say we are spending too much, let's reduce. I've yet to see anybody who says, I have done too much, I want to reduce. Everybody says, okay, let's just try to help it and then keep the level as it is now, because people are happy with the status quo. So it is a problem which we don't know. But what we do know, of course, is the problem is there. And of course, based on that, this 1.5 degrees, of course, was agreed in Paris at some point. And this was the famous Paris Accord, which said basically, you want to have these goals, 40% reduction of the greenhouse gases in 2030 compared to 1990, and then maximum 2 degrees increase in temperature, but then shoot for 1.5 degrees because we are not sure it may actually go to 2 degrees after all. Anyways, so this accord was basically agreed. And the challenges, of course, for energies that I want to discuss, based on these, of course, you have to keep that in mind, right? We want to basically get this 1.5 degrees and not beyond that point. So you have to keep that in mind every time you discuss energy transition. And these items that I have put here holds for energy of any sort. Whether you're talking about fossil, you're talking about nuclear, you're talking about solar, wind, whatever. There are several aspects you have to deal with. I start with the first one, which is a societal aspect. People usually ask the question about the safety of anything that you use, okay? People want to be safe when you're using something, except when they're riding the car, by the way. If you look at the number of car deaths in the society, nobody worries about it for some reason. So it's all psychology of people, by the way, also. It's very funny. The waste management, again, if you are talking about fuels, any fuel that you have, it has a waste, okay? You cannot show me one source of energy without a waste. So you have to do some management. We can discuss this, by the way. If you have an example, I will be glad to hear. Then you have the proliferation. Again, this proliferation is then more dangerous, let's say, with the nuclear, for instance, that people also discuss this because it has radiation. You know, you can make atomic bombs from it if you like. So it is a dangerous thing. But proliferation basically can be done with anything, okay? I mean, even if you talk about the fossil fuels, in principle, they can be used in rockets that you send basically and attack a country, right? That's also military use. Then we have the technical aspects. The technical aspects, of course, anything that you use should be efficient. People talk about efficiency of, you know, cars that you have. If you have a house, you want to make your house very efficient in the isolation and all these things. And the goal, of course, should be the CO2 emission should be minimal, right? You saw the graph from CO2, which goes up forever. That we want to sort of make a plateau or even bring it down. And then, of course, the developments on the energy source, right? I mean, you look at, again, if you look at solar panels, how do we make them, which are very good, basically, for the environment. These are the developments that we have to deal with. Of course, the same holds for nuclear energy, the same holds for wind. If you look at the wind mills, for instance, they have really increased the size. I mean, now they are talking about megawatts of production for one windmill, right? In the older days, we had 100 kilowatt, we would be very happy. And then, of course, the costs come in, economical, and these are the costs that people get worried about. Again, this is surprising, because when we talk, for instance, about the nuclear energy, I don't have time to go through the cost of nuclear energy, but if there are questions, I can answer them. But if you talk about the nuclear energy, one of the things that I'm sure many of you hear is that it's very expensive, right? And then if you look at the cost, you say, okay, it's very expensive, and it's maybe 10, 20% more expensive than fossil fuel. The price of fossil fuel just jumped by a factor of 3 last year, right? Did any of you die? Did you suffer now hunger? Nothing happened, right? These things happen. These are global effects, right? The impact is basically almost dismal. Of course, you can say, no, I'm just exaggerating. There's a lot of effect on the economy. What effect? Let's discuss them, right? So what I'm trying to say with this is that anything that you bring up as a problem with any source, put it in perspective. Let's just discuss it carefully. Do not panic if something is a bit expensive at a given time, if it has advantages over 10 years from now or 15 years from now, right? And this argument that people look at things very short-sighted, basically, right? What is the cause? Because I'm keeping my wallet, I'm careful about it just for next day or next month. That should not be a scientific argument anyways. But also for intellectuals, you know, you are going to be the leaders of the society. It would be very bad if you think short-sighted like this, okay? Put it in perspective. So again, I have basically a talk for 2 hours regarding every aspect for all the energy sources, especially for nuclear energy, but I don't have the time. I'm given 30 minutes to discuss this. So let me just give you some numbers to put things in perspective. The world energy consumption by sources, different sources are given here around the world. This is from 2017. The numbers have changed slightly since 2017. But this gives a rough picture where you have the natural gas, which is about a quarter of everything. You have the coal, which is again roughly a quarter. You have the oil, which is about a third of the consumption that we have. And then all these other ones that we are talking about are just in this little small corner, right? That we are putting a lot of energy discussing. If you look at this, this is a funny picture actually, because nuclear is named here. Hydro is also put here. The other renewables are so small, they just bump them all together, right? That's how bad the situation is actually at this moment if you talk about renewable energy sources. As I said, this number has increased in the past 5 years. It's about a factor of 2 larger, and this is going up. Andre Fay will talk about the acceleration of this number also, so we need to worry about these things. But as it is now, the numbers are not very large. We are still highly dominated by fossil fuels, okay? Now, if you look at this now, if you break into electricity, so there is about 30% of this, basically, this is energy, by the way. 30% of that is electricity, and then I subdivide it now. Electricity, and then you look at the electricity, the different source. Nuclear, basically, the share is about twice, because the nuclear reactors produce electricity in the first place. So that's why the share goes up. If you look at the United States now, you see the nuclear is even stronger. It's about a fifth of the total of the electricity. But what I like to draw your attention to is basically also these numbers. This is the total around the world, 24,000 terawatt hour of consumption, electricity consumption around the world, right? And look at this number. It's about a sixth of this number is just spent in one country. So this is, again, what I said about psychology of people. If you look at it, the per capita will come also later. The people are not spending less. I will show you as a function of time also later. But before I do that, this is the share of the renewables as a function of time for the past 20 years, basically. And if you look at the coal, just look. It's not even going down. If anything, it has gone up in the past 20 years, right? Which is a shame, right? If you think about this, that we have all these problems, you see that this consumption of the coal has gone up. Sorry, coal has gone down. The gas has gone up, sorry. The problem was, for instance, Germany came with this. This is, again, a deal that they made in the year 2000, 2001. I think they made the deal that we want to go towards gas. Gas is very clean, they said. I don't know why. I mean, if I'm a scientist, gas is not clean to me because you burn it and get CO2, right? Political effects. You should, as I said, if you study something, study the whole thing. Does anybody know why gas became very prominent in Germany? No, they use that to shut down the nuclear reactors. It's the other way around. They actually use another argument. Now, I'm generally not very cynical about these things, but Mr. Schroeder, who was the chancellor of Germany at that time, he became the CEO of the Gazprom in Russia. They made a huge deal beforehand when he was a chancellor, and right after he finished, he became the CEO of that company, earning his income by a factor of 200. I don't know what, actually. I'm just making up a number. There are a lot of factors which go into a game when you're talking about it. Just don't accept everything easily. Just study the politics around everything, numbers, and then you will come to other insights, as they say. Anyways, the gas actually sort of went up in the past, and the coal is more or less constant. If you look at this number below 40%, it's also 36%, 21. So the coal, which is the dirtiest of all, has not even changed in the past 20 years, all right? And then the renewables, of course, has gone up. What does this tell you? Which means that the consumption has gone up, right? Everything else is constant, and the renewables are going up. We are actually spending more energy, not even constant, right? So here is basically why we are spending more, right? I'm showing you the numbers from 1970. This is basically the carbon dioxide emission, starting from 1970. By the way, carbon dioxide emission is basically linearly proportional to the consumption, right? Roughly, if you look at it. So if you look at the world, you see, just pick up your famous country if you want, whatever it is, United States. Here, rather constant. If anything, it has gone. It has gone up slightly since in the past 40 years. It has not gone down. Okay, just to set the scene. Now EU 28, okay, it has gone down a bit. Okay, in the past 40 years. But look at these other countries. This is China. Look, right? Exponentially growing in the past 20, 30 years, actually. And by the way, they still have another factor of 4 or 5 to go before they reach our level of standard of living, right? So who are we to tell them you shouldn't do that because we are now rich and you stay poor because the earth is now getting polluted, right? So in that sense, again, these are the political aspects of the discussion, right? When you talk about these things, we cannot enforce their standard of living on themselves and keep it like that because we don't want to suffer from the consequences of what you will do at the end. Anyways, this is a very important number that you should keep in mind. And there is another one here. Look, India is coming up almost from 0 to this number. And it will go up even more because the population is increasing and they are getting richer, right? So you will see, my prediction is that, why is this jumping? My prediction is that the Indian system basically here will have this exponential coming up, right? And that basically puts the whole thing in perspective around the whole world, if you like. So just look at the other countries also. Every other country is also sort of coming up, right? The total also. These are other countries. They're not, this is China and India are separate. Everybody is actually increasing, right, in the coming years. Now, if you look at the per capita, and this was what I said, people are becoming very conscious We just had this discussion just before. Also, somebody told me that people are understanding this better. I said, fine. If they are understanding it better, they should consume less, right? If you look at it again, this is from 87 to the year 2010, I think. I don't know what it is actually. No, 2020. So if you look at it per capita, North America, this is per capita now, right? Is rather constant if you look. These are the units or gigajoules per head if you want, for those who are interested in units also. So the US is basically rather constant. Actually, this is Soviet Union, actually got better after the collapse of the communist system. Middle East is just linearly going up. If you look at this, Europe is rather constant, gone down slightly. So Europeans are actually the best boys of the class. So there we are going down a little bit, that's good. But the rest again, look, I mean, Asia Pacific, this is including China, per capita, right? This is not total now, per capita. They're also going up per capita, right? And they have to, they deserve to go up. Because if you go to China, they're getting richer, therefore they want to live better, right? So they will go up even more. And then the other lesson that you should take home is that there are countries around the world which are consuming like a factor of 4 or 5 above the average per capita, right? Now, if you look at the renewables, this is again the increase. So this is very good news because we are talking about 2000 to 2020. In a span of time of 20 years, we are really improving. And of course, Andre Fay will tell you we have to accelerate this even further. But again, looking at the units, this is basically 3,000 terawatt hours that we have at the present moment around the world. This is the total. And if you remember, this is the total. So already now you could say we are at the level of, say, 10, 15% of the total is renewable, okay? So, which is good. I'm not against this, it's good. It should be accelerated also. But we are a long way away from this number. And if you look at the countries now, these are countries specific again, to look at this, which countries are actually doing quite well. If you look at this, China, Asia Pacific, which is primarily China, is doing the best, right? Despite the fact that they are poorer compared to European Union or the Western countries in general, but they're doing actually the best. Just look at this increase. Europe is, by the way, this color. This color is the same. So this is less than China, what China is doing, okay, in the total, in the absolute numbers. Now, countries like Middle East, of course, they are sitting on oil. They would be stupid to actually develop anything other than oil because it's just coming for free. Well, I'm just being sarcastic about being stupid. Of course, they should do something about this. And of course, the other countries, the North America, which is the US here, or Canada also, included, are also doing okay. But China is still the best. Not that I'm a proponent of Chinese, by the way. I mean, don't take a mistake. Now, if I look at the energy consumption, though, there are policies. So governments have to set policies in order to continue. So we say in the Netherlands, for instance, by the year 2030, we need to have so much CO2, we need to have so much of whatever, right? So they set the policies. If we take the policies as they are stated now, this is basically the number of megaton oil equivalent. This is as just a unit in energy, doesn't matter what it is. Just increasing, basically, this is historical, right? This year, actually, this was done in 2018, I think. But anyways, we are sort of increasing, and then if you don't do anything serious, we will just increase even more. Here, I am assuming 20% becomes renewable. So it is going up compared to now. I just told you it was 10, 15%. So even if you go up as we are talking, it's still not enough. The amount of energy will just go up, and that's bad news, okay? This is just CO2 sort of emission if you look at it like that. So I would say just forget about the Paris Agreement. We will not be able to make it. And in fact, Mr. Trump actually made the announcement, we are out of the Paris Agreement because he knew he's not going to make it. Coming back to the reality now, again, government policies can change. Acceleration in renewables, that will be discussed in a couple of hours by my colleague. So if you do that, then of course you can say renewables should be 30%, 31%. This is a scenario, 31%. But if you pay attention also, the nuclear, which is presently 5%, should go to 9%. So in any model that is developed to reduce our CO2 emission, nuclear is included. You cannot find one model in which nuclear is not included, okay? So in that sense, I would say it is there, you have to live with it. The question is how to live with it and what are the problems, risk, and all these things that people are afraid of. But okay, if you can do this, by the way, then the CO2 emission here in the 2040 will be then the goal of the Paris Agreement. That's what you have to do in order to get to that agreement. Okay, that means you have to change. You cannot continue with the present policies. That's basically the message. Then, of course, we can say we are trying to say. Again, this is just the same picture, but then a different way of showing it. That here, this is the stated policies. This is what we have at the present moment. I just show you the solar panels here. So this has to really to go up. Here is the wind. It has to go up. But this is, I just told you, this is not enough. If you want to save the Earth, basically the solar panels should go up by this rate and not this rate. The wind should go up by this rate and not this rate. And nuclear has to come up like this, as I said, a factor of 2 more than what we have at this moment. Okay, so you need to have these working scenarios in order to convince the politicians, set it through like that. We need to accelerate, but we need to accelerate on all fronts, right? We don't have the luxury, and this is one of the problems that I have with many discussions, including our own colleagues sometimes. They say, look, if you just put all the money in solar, we'll be there. If you put all the money in wind, we'll be there. It's just not gonna work. This is my, hard statement that I make, and I will try to convince you also by showing all these facts. Again, coming back to coal, and the reason I'm showing this coal several times, at the end you will see why I'm doing this. This coal, again, if you look at it, this is the megaton, doesn't matter what the units are again. Megaton of coal, basically. This is a global consumption by different regions. But just look at the total. Starting from 2000, going up, 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 up. Of course, China is the biggest user because they need the energy. They're developing their industries. They need the energy. And whatever they do the best in the renewables. They still need more. Therefore, also the coal goes up, right? So their coal is going up, everything. The rest is rather constant. It's not going down that much, by the way, despite the fact that everybody knows coal is very dirty. The total is sort of going up and then staying constant. It's not going down, right? And that's what I mean when I'm talking about policies. Now you know why I'm showing this, because Germany just stopped their last nuclear, and then what are they replacing it with? Nobody follows the news? Coal, right? So this is exactly the problem that we have. Politicians are making policies not based on scientific facts. Very often they get emotional, they close something and they don't know what to do because they have decided to close, they cannot back out anymore. And what do? They start doing something which is rather stupid. Everybody agrees it's stupid, but they still do it. And they get the votes also. That's even more stupid. Okay, anyways, this picture you should forget. If you look at now nuclear electricity, so because my topic is nuclear energy, so I probably should go there fast. So this is the total of the power which was generated, 25%. So 1/4 of the European electricity is produced by nuclear energy. If you are very much against nuclear energy, actually, you should turn off your lights tonight. Because half of your energy, probably electricity, is coming from France, which is nuclear energy, okay? So this is 25% in Europe. 14 member states basically have nuclear power plants. Actually, I think it's now 13. Germany just finished. So this slide was made just the day before yesterday. 128 nuclear reactors produce about 120 gigawatts of electric power. And there are under constructions 4 in EU, and there are plans for much more. And then 10 in Russia and Belarus. Okay, we have at this moment, of course, no contact with them anymore, so we don't know what the hell is going on. If you look at this table, which I like actually very much, this is the climate change and nuclear energy. So if you look at the CO2 emission, right, in the world level, at the world level, and this was done in 2016, and then you can see how much of the electricity had production of CO2, and how much of it was CO2 free. So 81% and then 19%. How much of that was nuclear? How much of that was bio and all these things? So this is just a table around the world. If you look at the EU, of course, the number is getting a bit better than the average of the world. If you look at Belgium, you can see that this number is given, is roughly the same as the European average. France is much better, right? 53% CO2 free. And then Sweden, 71% CO2 free. So these are the countries which are doing quite well in Europe. And if you look at these correlations, by the way, you see that France and Sweden, they also have the largest share of nuclear energy in their sort of basket of energy. right? So there is a direct correlation. If you talk about, if you have nuclear energy, you have less CO2. There is no discussion about this. This is well known. Of course, you can say, I take nuclear power plant out and put solar, for instance, there. But we can have this discussion. This is not possible. Okay, so this is basically the message that you should take home. Of course, Sweden is even better than France. Do you know why? Yes, Sweden has something else which France doesn't have, and that's hydropower. So again, they basically use things that are really CO2 free, and then they have the best record. Now we come back to the Netherlands, and this is basically the renewables in the Netherlands. If you look at the year 2000, there was 2% of the gross final energy consumption. 2% was renewable, nothing. If you look at it, 2020, of course, the number has gone up in the past 2 years. 2020, you are talking about 10%. But if you look at this division which is in there, this huge number is biomass. Biomass is now known not to be very friendly, right? Because it still is not in the CO2 cycle. If you calculate it, it's not CO2 free. Therefore, a lot of people are not putting it into the list of the CO2 free sources. But anyways, look at the other ones which are very good, wind energy and then this solar energy. You know, you're talking about a couple of % of the total energy. Despite the fact that you see almost on top of every house solar panels, right? This is basically the number that we are dealing with. Of course, this number has increased by a factor of 2. But if you look at now the Netherlands compared to other countries, again, despite the fact that we have all this discussion about we are green, we are good, if you look at it compared to other countries, actually, the green is basically here. This is the Netherlands, you know, this is Germany, Spain, Belgium. We are actually, this is the average of the European Union. We are the worst, right? Did you know that? Because, you know, when you listen to the, you know, news at 8 o'clock, you know, I get the impression that we are doing quite well. But okay, this is what it is. And then if you look at this, now you look at the European countries, you see the Netherlands? Here, okay? We are really at the bottom of the list. And this is the reason why colleagues like Andre Fay are also fighting. We need to accelerate. We are really in bad shape, okay? I don't know whether he will show this. Coming to the risks that we have, CO2 emission, I compare now different types of sources. So this is a sort of brown coal or dirty coal, oil, natural gas, solar, everything is listed here that you can think of. And then here is basically the emissions that you have, the greenhouse gas emissions, and the units are tons of CO2 per gigawatt hour. So it's normalized the amount of generation of electricity, right? Then I can compare. And if you compare them, look at these are the numbers and averages, basically the bars are averages, and these are the error bars which are put there because of the model dependencies that we have, because the model uncertainties we have, we don't know exactly what we should put there. So they put this error bar on top of that. If you now compare these basically together with these error bars, doesn't matter. You see clearly that all the fossil fuels are bad, including the natural gas, which Mr. Schroeder was so hard fighting for. And then you go to these other ones, which are basically solar and the biomass and all these things. Again, the bars are small. There is a huge error bar on the solar because there is a big discussion. What is actually the amount of dirt actually that is produced when you are producing the solar panels, right? And that is basically actually the master topic discussion of my student who is sitting here in the audience. You can ask him a couple of months from now what the results are. So we are looking at this. Many people are looking at these things because there are many uncertainties, okay? So here I just put it in a different ways. I'm just showing you the number of deaths from air pollution and accidents, normalized to terawatt hours, and then the equivalent CO2 emission, this is gram per kilowatt hour. So everything is normalized properly to the amount of energy that we use. And again, you are using the same thing, you know, brown coal, oil, gas, all these things. And look at the nuclear. It's basically sitting at the corner, 0, 0. Normalized, I'm saying. Of course, the number of deaths could be large, but this is normalized to the terawatt hour or the whatever the production is. If I put on another scale here the number of deaths per terawatt hour of electricity made, this is a more recent number actually. Again, you see the brown coal, oil, gas, and all these things. Look at all these numbers. This is per terawatt hour. If you look at it, you're talking about 1 million deaths if you look at the amount of electricity produced. by brown coal. If you only use brown coal, you're talking about 1 million deaths per year just from the production and the accidents that you have, not from the pollution, the air pollution, yet. That number is not here. It's just the production. Okay, miserable. And then on this scale of things, look at all these renewables and nuclear. They're all at the level of sort of 0 something, right? So it's I would put it as sort of negligible. Okay. Again, you can compare this. Of course, nuclear is a factor of 2 more than wind, but okay, nuclear, Chernobyl is included here, for instance, as an accident, as a major accident, and the number of deaths are estimated and put here. Okay, so the nuclear waste is another one. So the accidents are what it is. I will come back to the famous accidents soon because that's very important to put it in perspective. But the waste, again, if you look at for instance, the nuclear waste in the Netherlands, we have this Borssele power plant, which is in the south of the country or southwest of the country. And this basically produces 0.5 gigawatt, roughly 0.5 gigawatt of energy. It's not a big reactor. But the waste of that reactor is basically 1.3 cubic meter per year. Right? That's basically what the amount of waste it is that you produce from this reactor. 1.3 cubic meter per year. That's basically this thing, right? That's the amount of waste that we produce. Now the question is how to keep it there and all these things. I don't have time. How much time do I have, by the way? 10 minutes? Yeah, we'll be finished. So it's of course, depending on that, of course, how to keep this and all these things. There are many, many discussions going on. There's one, I just show you one site, which is actually being built at this very moment. It will be operational this year. And this is Onkala site in Finland, where they are using the now closed one, the Finnish open one today, right? Just to say to Germans, you are doing very badly. Anyways, so this is next to that site, the nuclear reactor, of course, and then you can put a lot of nuclear waste if you want. And they have done many, many studies, by the way, that this should be safe for the next 1,000,000 years. And we are talking about 1,000,000 years, so I don't have time. If there are questions, I can answer what the problems are. But let me go to the safety. So the waste, as far as the managers are concerned, of course, there is a problem in a sense of how to transport it to certain sites, but the knowledge is there, techniques are there, and practice is there. Finland is one example, but there are many other sites, for instance. The Dutch still are at the surface. They're not going under for obvious reasons, because once you dig, you just hit water very soon, so they have to go very deep. But there are other geological sites which are being studied at this very moment. If you look at safety, this is basically from 1955 to 1995. This is the body burden of cesium-137. There is sort of degree of radiation which is measured just to show you what we can measure if there is a nuclear explosion, if you like. And here, by the way, this is Chernobyl, right? This is Chernobyl, and then of course it's a disaster. But look at the time where the Cold War was really at its peak, right? And these are basically just the nuclear bombs which were being tested left and right in many, many different regions on Earth, right? And this is basically what has happened in those years. Of course, after Chernobyl, nothing else happened until Fukushima, which resulted in also some release, but it's not, actually on this scale, it's not visible. This is Fukushima. So this is a reactor which was built in I don't even know, it was operational in 1970s. So it's technology and the design was from the 60s and 50s, basically. Very old design with the known problems. This is just a reactor. Basically, this is the reactor core, basically. And the water pump, which basically sort of made this problem. The pump was put in the basement of this reactor, right? This was a design flaw that was known also at that time, right? At that time, I mean long before the accident. But okay, the design flaw was known. On the other hand, people do calculations of risks, right? So there was a calculation done on the risk. What is the chance of having a major problem if there is an earthquake? Now, the calculation showed it's about 1 per million. What is the chance if you have, for instance, a tsunami? Calculation showed it was also 1 in a million. Of course, the problem was that both of them happened at the same time. So the earthquake, of course, shook the building, and of course, the water just came in as a result afterwards. Not as a result of earthquake, but tsunami, which is earthquake in the sea. Anyways, accidents happen, of course. You cannot deny accidents happen, and it has consequences, right? Again, this is a very old design with known flaws, right? Also at the time of operation. Not at the time of design, by the way, at the time of operation. And the result is, of course, that this is the region, Fukushima, and then they had to evacuate about the radius of about 50 kilometers, radius of 50 kilometers around it. So that area is not inhabitable anymore for the present time. So there are people, of course, our colleagues are also doing studies, continuous studies to see what is the effect of radiation at the given radius as they are sort of sweeping the areas. These are all measurements that are done. And here, this is just, by the way, the scale. You can see also when you are at the level of 50 kilometers, the radiation levels are also quite low. Okay, so these are accidents. But before I go to this one, which I want to do a test, right? Accidents, of course, are everywhere. Again, put things in perspective when you're talking about accidents or anything like that. So first question is, some people know already from me, so don't even say it now. The chemical accidents. Name a very big chemical accident. Okay, just to, yes? Name the accident. Okay, how many people died? Okay. Name a nuclear accident. Everybody knows, of course. So let me just get this chemical accident just out of the way. Bhopal, which is a chemical factory in India, had an explosion, 1984. I was a graduate student, by the way, at that time, because we woke up to this horrible news. In one night, 4,000 people died because the accident just suffocated the gas that came out, the fume and gas, killed 4,000 people on site. On site, I mean, people were sleeping in their houses. They killed. Up to today, there's 500,000 people with long-term injuries. Up till today, which is 40 years later, there are lawsuits which are still going on from Union Carbide. So if you didn't know about this, look it up. Nobody talks about it because it's a fact of life. We have to live with chemical industry, right? Now, talk about energy. Name the worst accident in energy. Of course, everybody says Chernobyl. Anybody knows? You know, if you know it from me, don't say it. If you know it from yourself. No? Banqiao. Anybody has heard about the name? No, that's even worse. 1973, Banqiao Dam, basically, this is the name, by the way, Banqiao. It actually just ruptured. This is energy related, right? It was a dam for production of energy. It ruptured. It killed 170,000 people. And nobody knows about this, right? Okay, that says enough, right? I mean, this is just put things on scale. And then now, of course, you can go to accidents on anything. Put things in perspective. In the US alone, more than 100,000 coal miners have been killed up till now, right? When we talk about sort of an industry, and you talk about sort of what is the problem with an industry, you have to integrate over a certain period or the history of that industry, right? And then you see the numbers. Put it in perspective. Don't panic, of course. I'm not panicking if I see, for instance, Bhopal happened, I'm saying, oh, no more chemical industry. Then you cannot drive anymore, because once you sit behind your car, 30,000 people get killed on the American highways every year. That's 100 per day, right? But people are still driving, right? And there is, I don't know what it is. It's a psychological effect that people like to get attracted to some accidents and not to other accidents. This is also a psychological effect. But you, as a student, of course, have to be above these things. Put it in perspective. Anyways, worst of them yet is the fossil fuels, right? This is what we have today. This is the waste. We are talking about nuclear waste, which has not killed a single person yet, and there is so much discussion about it. Also, rightly so, by the way. We need to discuss all these things. But the fossil fuel has this waste called the pollution, right? Up to 4 million people die per year because of the fossil fuel pollutions, right? I mean, this is 4.3 premature, there's 3 million deaths. I mean, at some point, I don't even keep up whether it's 3 or 4 million. We're talking about 1 million people, right? And I don't know the precision of that. My resolution is about 1 million people, less or more. And we are talking about accidents which have killed 20, 30,000 people, maybe. Yes, it's there. We need to make sure it doesn't happen. But that we need to make sure with everything, okay? Put things in perspective. So if you take that message from me, now I come to government policies, which was part of my title. On the nuclear accidents, there was this. These are actually the only 3 major accidents. There have been some minor incidences like any other industry. These major accidents, one was 1979 in 3 Mile Island in the United States. The opposition grew, of course, against nuclear energy, but it dampened a bit afterwards until Chernobyl happened, of course. And some plants were frozen. This was the government policies of freezing some nuclear power plants because they panicked. Maybe we should look at this carefully, which is correct, by the way. I'm not saying that if there is an accident, you should just go happily ever after. No, if there is an accident, you should stop, think, analyze, but then move, right? But because unless the reason, the analysis says you should not do it anymore, that's a different issue. But then the analysis, no analysis came that this could be a major problem. Yet, many plants were frozen. And then Chernobyl happened in 1986. Immediately after that, when it happened, people get emotional, right? It's like the plane crash. When the plane crashes, the day after, you have a bad feeling if you sit in the plane, okay? It's emotional, it's psychological. So the Dutch government closed actually this reactor in 1997 because of that. Of course, it takes some years to shut it down, but they shut it down. Sweden decided to phase out the nuclear, but as you saw the number, good thing that they didn't do it. Otherwise, they would be one of the polluters now. So they backed out of this plan and they kept their nuclear reactors. And then Italy did close, they phased it out and they closed eventually. And then Fukushima happened. Of course, the German plan happened before Fukushima. So I put it here as a German plan after Fukushima. But the German decisions to sort of phase out or reduce nuclear happened because of political reasons, actually because of corruption, I would call it. Because Mr. Schroeder was really pushing to get the Russian gas into Germany. You all know about the Nord Stream, right? So it was all political. As far as I'm concerned, I have not seen yet a study which says that that decision was based on any science. But the Fukushima happened, of course. Mrs. Merkel, who I trust, I mean, she's a decent and her integrity is not questioned by me. She panicked. Right? I mean, Fukushima happened, then she said, no, we decide now we shut everything down. Despite the opposition, of course, that many people said, don't do it, right? Because we will have problems. The Russian invasion had not yet happened anyways. But okay, they decided. It's very political, it's very emotional. The estimates were made in 2019 that 1,100 extra deaths were coming because of her action. Per year. And the cost was 12 giga euro also per year for the damage that this decision made to the economy. People, again, don't put things in perspective. That's my problem, right? Put it in perspective. Something happens. Let's have a discussion, a social discussion, whatever. Don't do stupid things. They close it down. Belgium decided to phase out, but it's delaying the plan because they now see the problem. That we were a bit naive in thinking that we can just phase this out and put other things in there. Japan first decided to slow down and even to stop nuclear power after Fukushima, but now they are actually expanding because they see the same problem, right? They cannot accelerate enough all these renewables, and they are doing this. This you have seen before? Yes, I'm finished. Yes. This you have seen before, government policies, right? They shut down nuclear and they destroyed a village January of this year to get more coal from the German mines, okay? And even Greta Thunberg was, screaming there not to do this, not to do this. And for those who have any doubt that this is new now for us, I just put a quotation from Hans Blix from 1986, after Chernobyl. And if you just read the last sentence, an increasing number of serious scientific studies indicate that we are faced not with some theoretical, but a very real problem if we continue with the fossil and just have this scare about nuclear energy. This was already said in the 86 period, right? But okay, again, people panic. There is green movement, there is this, there is that. Many of the activities get stopped. So I will not talk about the nuclear alternatives. If there are questions, of course, come back to me later. Thank you for your attention.
That was wonderful. Thank you. We have some time for questions. We can start with the questions from the audience who is present, and we can then go for the... Yes. Okay. So the way we're gonna do this is by this nice box. I'm gonna throw it to you. If someone has questions, please. Someone have questions, please. No, you don't have to. Okay. All right.
Or you can ask questions about the parts I missed. Sorry.
Yeah. Let's go.
Good catch.
Okay, does this work? Okay. Yeah, I was wondering about your, because you mentioned thinking on the long term with regards to energy. So considering the very long term, how long do you think we will be using nuclear? Do you see it as an intermediate source of generating energy, or something that we should consider for hundreds of years in the future?
Well, I'm generally a person who does not exclude any options, right? In science or whatever technology, because once you exclude something, it will be extremely hard to build it back again. Like what the Germans did now, it will be extremely hard to recover. So not with that mentality, I would say, up until 2050, there is no way that we can do without nuclear. There is no way. So that means 30 years already down the line with a lot of developments which come in. After 2050, depends on the developments, right? I mean, it could be such that we still don't know the long-term effects, for instance, from solar panels, right? The first generation of solar panels, actually my graduate student is doing studies on this sort of waste, right? The solar panels will be phased out in 25 years. What do we do with this huge volume? I mean, the waste that comes in. Is it all doable and all these things? Questions will come up. And suppose that the results of those questioning will result in a way in scenarios that say, this was not the best solution. Then we have other solutions to continue with. Do not exclude anything. I'm not saying that will be the answer to that question, but the answer could also be that solar is very good. We should even expand it. Fine. Let's just phase out the nuclear. But my question still remains, even then, because the nuclear, as I said, I did not discuss the nuclear techniques, which are also developing as we are talking. And then if there is a technique which has solved the question of the waste, which has solved the question of explosions, which has solved all these questions, which are being solved, by the way, why not use the nuclear energy as a source? One thing we need to have, by the way, is to have a baseline. I mean, I didn't discuss all the technicalities, but you all know, right? I mean, the wind and the solar, of course, they have peaks and valleys, right? In the valleys, we need a baseline. What is the baseline now? Germany goes for coal, right? This is stupid. We need just a baseline, and this baseline for the next 20, 30 years until hydrogen is completely developed. By the way, we are also doing, in our institute, we are doing hydrogen development, all these things. So as I said, all the options should be on the table. We are not in a position, a luxurious position to say, look, I have another 10 years to think about this problem. We don't have that. We have minus 30 years, actually, if you think about it, right? We are already late. Therefore, all the options should be on the table, done and discussed at the same time. Not just put a hold on it and discuss it first, everybody convincing everybody, 7 billion people on Earth, before you can proceed. This will never happen. That answers your question?
Yes.
And there is life after 2050. Suppose we get to 2050, we will also need energy after 2050, and maybe even more energy. The Earth's population is also going up, by the way. I didn't discuss all these correlations.
Good. Anyone else?
Get the box.
Thank you.
This is for the online.
Okay. All right. No, my question is mainly about what about battery energy storage? Because that is also increasing in the upcoming years. They said
what type of batteries?
Lithium batteries.
Okay.
They say, at least this is what the International Energy Agency said, that by 2000 they're going to be the fastest growing source of power system flexibility by 2050. But that also consumes.
In fact, studies are done also on the lithium, the amount of resources we have, how much lithium we have in the Mother Earth, right? If everything goes into this battery direction, we will not have enough lithium. Just convert, I mean, the numbers are known. Just convert this, the number of terawatts I said at the beginning, and then put them in a battery and see how much battery volume you need, and then see whether we have them on Earth or not. So there are a lot of discussions on resources also. For instance, the wind is another problem, right? When you do wind in the sea, which is fantastic, you can get per windmill, say 4 or 5, even megawatt at this moment, which is great. But these, have you seen the electricity lines which come from the sea? It's about this thick of copper, kilometers long. And then if you say this is a good argument to use, I would challenge you to do the calculation to see whether we have enough copper on Earth to do this. Of course, we don't have enough copper. We do have enough copper, but the price will go up like this, and then it's not economical anymore, right? So as I said, every source that you can think of, you have to put things in perspective. Hydrogen may be a solution because we have infinite amount of water, you could argue. Of course, it's not all, it has to be desalinated. You know, there's a lot of processes which are going on behind that also. It is an option, but then you get the hydrogen, of course, the hydrogen batteries, basically, hydrogen tanks have to be everywhere. You know, when I was younger, by the way, and I wanted to have a hydrogen target for my own experiment, you know how many inspectors I had just turning it down because the safety issues and all these things. So also hydrogen has this problem because it's highly flammable, and if it explodes, it can explode the whole neighborhood, basically, right? Okay, I mean, again, these things have to be tested. Do not exclude anything. Test them, and then study them 10, 20, 30 years from now and see which is the best solution to keep. So keep all the options. But I'm not sure if lithium is alone enough, by the way. Okay. I'm not convinced. I need to see the numbers.
All right, yeah, we have a question on the back. Can you please throw it?
Where are we going? Thank you. Aren't we a little bit late to come to this conclusion that we need nuclear energy? Because it takes at least 15 years to build a new energy plant.
Are we late? I mean, this discussion, of course, we had, that's why I put this Hans Blix's statement in 1986. After Chernobyl, he was against actually the shutting down of any nuclear facility because he realized that these things take time. You should not really go stupid and not do anything, just continue, I mean, study, analyze, and just continue. And this was already known. Also, the global warming was known, by the way. The physics Nobel Prize of a couple of years ago was given to scientists which predicted global warming in 1960 something. I forgot the year, exact year. Their paper was published when I was just born, all right? People knew about this, and this is the problem. And now you ask the question whether it's late. As I said, we are already minus 30 years. We are 30 years too late, if you think about it. This we could have stopped 40 years ago, by the way. We could have stopped, we could have changed the policies properly 40 years ago. It didn't happen. But it's never late in that sense, because now you understand this. There are a lot of basically developments going on in carbon capture from the atmosphere, right? So let's finance these projects also. And don't worry about the cost, because we need to capture also the CO2 from the atmosphere to reduce this effect. We cannot just go on and even keep it constant. It will increase. So we have to capture it back, otherwise we'll have problems. There is a group in our institute, by the way, working on the capture. I don't know whether the students are involved in that or not. I'm sure some of you may be. Up.
All right, we have time for one more question. Could you please? Yes. Thank you.
Yeah. You kept talking about risk, but the biggest issue that you have when you live in a democracy as we do is that risk necessarily is not the biggest issue, but mostly perceived risk. As politicians follow voters and not just do whatever they want, they can't just immediately just ignore them and then just say like, oh, we should just go with nuclear because it is by the numbers the safest. If an accident were to happen, then you might have voters changing their minds. So they can't really ignore it. So could you comment on that and perceived risk and how that would affect it?
Yes, I totally agree with you. It is a perceived risk by people because on average, by the way, somebody who has not done mathematics and all these things really with a strong background in mathematics cannot estimate the risk. It's not easy to estimate and understand the numbers to the fine details. Therefore, the masses in general are not even in the state of estimating these things. That means it is brought to them by somebody. I don't know if you ever watched this program called Lubach op Zondag, but those who have seen it, of course, then they know he had one issue, complete half an hour spending on how much money is put by fossil industry into propagating against renewables and nuclear. So it's, when you say it's a democracy, I accept it's democracy if it is really democratic. And I do question the way, the processes which are going on in the society in that democratic process. If Shell has the power to put 50 million a year against these things, and I, as a professor, can only talk to you guys, right? Who wins, right? So is this process democratic? I don't know. So I also put that a bit, more carefully stated. I would state it a bit carefully. But it is perceived. What you say is totally true. It's what you perceive as a risk, but then somebody gives you the facts, right? I mean, you as a student is not. I'm talking about the general masses, right? Somebody gives the facts to people. When I was a graduate student, this Chernobyl was so, of course, also as I said, we should not underestimate the gravity of the problem, right? But we are scientists, so we really grab the problem and we try to analyze it and come with a conclusion and see what the problems are and how to fix it, if they're feasible or not. If not, then we drop it. If it is fixable, then we fix it and move on. That's a scientific approach. But if you look at how much propaganda was made, actually, it was the party night of Shell when this happened, because they had to spend a lot of money against this sort of activities, and then Chernobyl happens by itself. They didn't have to spend any money. They just needed to say, this happened. So it is this sort of picture, or the perception is also sometimes made, right? Actually, it's always made. Perception is made, right? And by definition. Unless you do a calculation of a risk, then you create it yourself and see how it is. So I hope that answers part of the question, but we can discuss it outside.
Actually, we don't have more time. Thank you, Professor Kalansara.
Yes, thank you.
I hope you have improved your view on nuclear. I'm sure that the students of EES had already a positive view of nuclear, but also I hope the people from outside of our master are now more informed about nuclear. We will have a 10-minute break and 15, okay? And yeah, we'll come back in 15 minutes. Thank you.
All right. Can you guys hear me? Yeah. Okay, I hope we all had a nice break. I would like to apologize for the lack of refreshments in this break. There was a slight hiccup with our catering, but during the networking session, there should be the drinks and the snacks provided. Okay, so now I would like to introduce our second speaker. As you can see, he's an online speaker. It is Till Echler. He is part of E3G, an independent climate change think tank that with a global outlook. His work focuses on untangling the implications of political development at an EU and national level to identify opportunities to push for more ambitious and robust climate change policies. So without any further ado, can we give a warm welcome to our online speaker, Till Echler.
Thank you so much for the introduction. Just a small heads up, I don't see you right now because of the sharing mode with Google Teams. So if there's anything, you will have to make noises so that I'm aware and can stop sharing to see you. I will just go ahead. I think everything should be fine. If you don't see the slide, then let me know, then I can fix it. My name is Till. Thank you for the short introduction. I work for E3G, which is a think tank. We focus on climate politics. Our goal is to basically build coalitions cross-cutting across businesses, governments, NGOs, and like broader coalitions to overcome political obstacles. And I think that ties very well to the topic of my talk today. We are trying to focus on the political challenges in the transition and less on the technological or innovative challenges that we are facing at the same time. So with my talk on this topic, I would like to seize the opportunity to talk with you a bit more through the politics that we have been experiencing in the energy crisis that has been triggered or aggravated by the Russian invasion of Ukraine. And I would like to do that by focusing on these four elements. I will give you a short recap on the European decarbonization agenda, which is basically the European Green Deal, to give you a short reminder, okay, what are we actually, where are we going? What do we want to achieve by when? And what are basically the means to get there? Then I will give you a short recap of my understanding or like of some highlights of the energy crisis that are relating to this decarbonization agenda. We'll talk a bit then about where do we stand right now. And then for me, really important for you to take as a takeaway from this talk is then raise some political dynamics at play during this crisis policymaking mode, and to better prepare you understanding the political dimension of the most likely next crisis that will happen at one point, and then understanding what are the political dynamics. All right, then let's get started. So the decarbonization agenda, or like put differently, the European Green Deal is basically the objective to be climate neutral by 2050. And the current European Commission President Ursula von der Leyen, basically framed the European Green Deal as her legacy moment when she was taking office in 2019. And to get, sorry? Was there like a remark or was that nothing?
No, we didn't say anything.
Okay, all right. Okay, that was like a noise. Okay, I was just perfect. So in order to get to climate to climate neutrality by 2050, the European Union decided to have a target by 2030 to reduce 55% greenhouse gas emissions compared to 1990. And in order to achieve this reduction in greenhouse gas emissions, we have a certain package, and that's the Fit for 55 legislative package. It comprises new regulation when it comes to pricing models, like for example, in the revision of the European emission trading system. But it also includes targets like the Renewable Energy Directive, increasing targets for energy efficiency. And we also have some regulation when it comes to the allowance of new cars with internal combustion engines that are going to be phased out, and some supporting measures like funding for innovation and so on. So this is basically the goal and the way there and the path, and including some of the regulations along the way. So now let us look at the energy crisis and some of the implications. So I hear like a feedback. I don't know whether this is just from my like whether you hear that or not, but maybe someone isn't muted or something. I will just continue talking. If it's very annoying, you have to let me know. Then we have to fix something. I think it's better already. Okay. So what we see here is like a decoupling of Russian energy, or like Russian gas primarily, which has been a trend, but which has been very strongly aggravated since the invasion of Ukraine, beginning of 2022. And I wanted to just show you how drastic this reduction has been. So of course, the energy crisis basically comes from the fact that we decided as European Union, okay, we no longer want to rely on Russian gas. So we have to do something to get away from this energy source. And this is basically one representation of this drastic shift in energy supply. This energy, like this shift away from Russian gas, had a strong impact on prices. Here is the spot market evolution of gas prices, and we see this very remarkable peak in August 2022, which has been going through the media a lot, of course, because it has strong implications not just for households and households consuming energy, but also for industry having like a hard time to survive in that environment with energy prices that high. And also with that slide, I wanted to show you give you an understanding that the lack of gas from Russia basically led to a shaking up of energy mix in general. So what you see here is basically an overview of the gas demand that was not met by Russian gas, or like because of the absence of Russian gas, basically, across three sectors, like the power sector with electricity generation, building sector, and industry. And what we see in the top line, in the power line, is basically that in addition to the lack of gas, we also saw during 2022 that energy sources, hydro and hydro and nuclear were also like not delivering what we were hoping that they would deliver. So we actually had an increase in further aggravating of a lack of supply for energy. And on the left side, this is, I think, very interesting because you see that there has been a whole combination of factors that helped us to get through the energy crisis so far. Again, split by the power, the buildings and industry sector, we see that deployment of more renewables played an important role for the power sector. We also used more coal to produce energy and electricity. And we had some supporting factors, efficiency gains, behavioral changes, or like mild weather. The same for the building sector, where we had like a strong impact from mild weather during the winter that helped us to reduce the energy demand. Some behavioral changes, people reducing temperature in rooms, for example, or like some fuel switching. And in the industry, we had like a strong aspect of product curtailment. So basically industry saying, okay, for that price of energy, we cannot produce any longer and we will have to stop, at least temporarily. And that is basically a reduction of demand in the industry side. So all of this basically just to show you, okay, so implications of the energy crisis on Europe and the European Union. And here's just an overview slide of some of the measures that have been taken. We can categorize them by supply side measures like diversification of gas, as I was showing you in the beginning. We can also talk about the increased deployment of renewables, of course, that would also be supply side measures. We had some demand side measures, basically reducing energy demand, either via technical solutions, increasing energy efficiency, for example, insulation of buildings, but also like behavioral measures, basically appealing to population to reduce their energy demand or avoiding energy intensive products, for example. And finally, we had like a block of measures by member states or like by countries and by the European Union to basically cushion the negative impact. So basically providing income support for poor households, trying to cap price developments at the market. There's also different dimensions. I will not go into that into detail there, but if you want, there's a proper analysis of different measures in this link by Acer. And also some windfall tax, basically increasing the budget for member states or like for countries to then respond to provide support for poorer households, for example. And I want to show you this those measures, because now when we would go back to the question, okay, so what are the implications for the decarbonization agenda? So what are the implications for the European Green Deal? It is, we have like broad facet of possibilities. We see on one side, we have increased ambition partially. We see that renewable energies have increased ambition now for permitting to speed up the deployment of renewables via faster permitting procedures. We have a strong momentum for clean tech industry, with facilitation and funding support. And we still talk about the European Green Deal as an important project ahead. Which is not a given, because in times of crisis, and especially when we have a war in Europe, it is important to see the links between the different crises and not just start like, okay, now we have to reprioritize and we get away from the climate agenda. At the same time, we also had like a lot of dynamics that are not really helping for the decarbonization in the long run. Most notably, probably like the revert, like that we went back to coal and we used more coal for electrification, for example. But also the buildup of LNG infrastructure to import gas from other sources, where some reports now state that we have way too much infrastructure and we don't need that in that extent. But it has been the response to the crisis. So I listed those two sides because I want to highlight that, first of all, it's right now very early to tell whether whether the measures that we took actually advanced or like fast forwarded the transition to climate neutrality, or whether it actually threw us back. Probably it was a combination of both, obviously, but the long-term implications will only also be clearly visible in the long term. Because when we talk, for example, about the increased ambition when it comes to specific regulations like the Renewable Energies Directive, where we now have like a goal to deploy renewable energy by 2030 by 42.5% and not by 40%. This is of course like a measure that we will only see materializing in the years to come. And secondly, it's also very hard to find like an ultimate judgment about the situation, because the measures basically we are still in the process of this crisis response. So politics are still going on, and we are still in the moment of shaping new policies, making new decisions based on the energy crisis, how we have perceived it. And then we will only be able to identify what's going on along the road. So I wanted to highlight that it's not the idea that, okay, the crisis happened and now we have we have overcome the crisis and now we know where we are, but it's more like a continuous battle, basically, to push for the more ambitious and for the solutions that are helping tackling both crises, like not only the Russian war in Ukraine, but also dealing with the climate crisis, and at the same time trying to avoid path dependencies or basically negative dimensions that would basically make the way harder to attain climate neutrality. So basically, this is why I would like to talk a bit about what I was mentioning in the beginning, about like some reflections about the process itself. And I thought about three reflections. These you can see here, that I think have been quite visible in the crisis. And basically, I want to talk about that because I want to show you that when we have a crisis, there's a certain dynamic in policymaking. So decisions are taken in a specific context by decision makers, and they have a certain room to maneuver. And crises are always very special moments because usually you act under very strong urgency and there's very little time available, so decisions are taken. And I want to highlight those three dynamics to make you better prepared for the next moment of crisis, or the next moment of urgent action, to understand, okay, what's actually going on? Why did we decide to go this way and not that way? Why did we decide to increase ambition on that side, but we didn't really consider this option? And for that, I would like to take those three examples. So the first one is basically the statement, or like the assumption, that policymaking during crisis, is rather reactive and not really proactive. And I think one great example for this is the buildup of LNG that I was mentioning earlier. So we see that we have, for example, in Germany, that was heavily relying on pipeline gas from Russia. They decided, okay, we will stop now. And that has been really like a shift by 180 degrees, because before they were really like strongly clinging to the Nord Stream 2 pipeline to Russia that has met a lot of criticism already by partners from Germany, and nonetheless they stick to it. But with the invasion, they decide, okay, now we're going to change, and they shifted gears and they really focus on LNG now. So they have like this massive implementation of LNG infrastructure in Germany, but also across the EU, heavily relying on the US as a future importer of liquefied natural gas. So that means on one side we have a short-term crisis response mechanism. Okay, so we get gas elsewhere. Same time, it again makes us very dependent from individual suppliers, of course, and the carbon footprint, for example, of LNG is of course not that great. So like when we look at the climate agenda, we can see, okay, this is a very short-term oriented measure, and I'm not saying that it might not have been necessary, but still it will make some other policy objectives in the long run more difficult to attain, because we talk about, for example, the path dependency, the idea that when we have certain measures in place or certain infrastructure in place, they will be used, and it will be harder for us now to build down this infrastructure and the dependency on LNG than if we had maybe like taken a decision in another way. So LNG is a clear reaction to the crisis moment, where policymakers said, okay, we have to do something right now, and we will do this, and we will do it like in a very clear and very decisive manner. The second aspect, I think, is, I think you probably have heard the saying that crises are opportunities, and of course this is sometimes a bit cheesy to say, but there's some truth to that. And I was hesitant to say to put like opportunities on the slide, because of course those political changes that might happen, they are not necessarily positive. So one positive example that I wanted to give you here is Repower EU. It's basically legislative response package from the European Commission. So basically, the European Commission was saying after the invasion in May last year, okay, we have to do something because we have to get away from Russian gas. So we have like a bundle of of measures. And at the same time, what they did, what was positive, is that they said, okay, we also want to link that to the green transition. So basically, having the idea, okay, we can actually solve two crises with one approach. And that has been the positive opportunity, basically, to actually fast forward, or like to speed up at least the green transition, by tackling the two crises together. And so what we have seen since then is like an increase in ambition, like stronger targets for renewable energy deployment, energy efficiency, as well. The idea to have faster permitting procedures to make sure that not just the targets are increased, but also the way how we get windmills built, for example, is like speeding up. And we had some demand reduction measures, trying to get away from gas by lowering the demand for energy. And finally, the third dimension I wanted to highlight, the third basically lesson about the political process. And this is maybe a bit more abstract, but I hope you can follow me. If not, we can discuss it more during the questions. It's the idea that framing matters. And what I mean by this is when we as either the people or decision makers, and more specifically, we see the crisis and we interpret the crisis in a certain dimension, or like in a certain way. And the way how we understand a crisis, or like we understand a certain situation, this way will basically shape how we can respond to it. And this is called framing. So basically, how you see the world, how you describe the world, will have an impact on what you can do in this world. And one example to maybe make it a bit more concrete is on the left, you see here a statement from the European Council. The European Council is one of the three institutions within the European Union. And they basically have like a section on their website on the energy crisis, and they have this heading: energy prices and security of supply. And then they describe Europe has experienced an unprecedented energy crisis. EU countries are working together to secure energy supply and ensure affordable prices for consumers. So what you see from the way how they present their task ahead, they focus on prices and they focus on the security of supply. And by focusing on those two dimensions, they have a certain set of measures that follow from this. For example, increasing the supply and making sure that the costs are not rising into into spheres where it's getting really problematic and people cannot afford it anymore. So while this seems all very logic and seems okay, makes sense, we have to make sure that this is all going, that we increase supply and that we make sure it's not too expensive. Some other options are not less present. For example, we could also discuss energy demand reduction. So we could also make a frame where we say, okay, we have like this massive crisis now. We really have to structurally reduce demand. We all know that from the perspectives of getting to climate neutrality, we will have to reduce demand, energy demand. We cannot just solely rely on replacing supply from towards renewables, but we also have to reduce demand. And for that, it would have been an opportunity now to also frame this crisis as a challenge as a challenge, but necessary challenge to reduce the demand. And while this has been done to a certain extent, the main narrative, the main framing is about increasing supply and making sure that it's not getting too expensive, which again, it's not, I'm not morally judging this way. I'm just want to show you how people take, like how frames are existing and basically shape the way how we respond to the crisis. And with that, I would like to take one more minute and make my final remarks, and then I'm very happy to have take some questions. So basically, coming back to the original question about the implications about the decarbonization agenda, basically the European Green Deal, it's very clear to say that the European Green Deal is still there. Like we have not seen a complete shift away from of priorities and not caring about the climate at all. We actually managed to have some reinforced ambition and reinforced targets. So that's actually a very positive development. Of course, me personally, but also as our organization and a lot of more progressive countries were hoping for more ambition and for even faster transition towards green energies. But at least we are not we don't have to fight that the European Green Deal is still discussed. At the same time, we still need more ambition. We still need more in order to achieve the goal. Three concrete aspects would be: first, we have to develop national ownership, so that not just at the European level, the Commission says we have to attain this and we have to do this and that, but that we actually see member states, so countries in the European Union, to step up to say, okay, we will now really make sure that to attain our national targets. We have to find solutions to the investment gap now because of the crisis and also of COVID pandemic before. Public budgets are very tight right now, and member states try to reduce public investments. At the same time, we know that we need those investments for the transition ahead. So how do we find the space to really spend money where we need it? And finally, we have to find ways to look for co-benefits for different dimensions. So not just about achieving climate neutrality, but also do this in a fair and just way, and also ensure that European competitiveness is not falling away at the same time, so that the European industries actually manage the transition and will not end up in a spiral of deindustrialization. And last but not least, what I really wanted to bring home to you today was the idea that, or the suggestion or the invitation to try to look at the politics that we see in times of crisis. So when people step up and say, now we have to go back to coal, or now we have to do this, or we have to do that this all happens in a system where we have different actors with different interests. Those can be governments that, for example, heavily rely on nuclear at home, or that rely on gas, or on any other energy source. Can also be political parties that try to step up their influence, businesses, NGOs, and they all come together in those crisis moments and try to see, okay, now we can do something in that way or in that way, because right now there's uncertainty, so we can do something else. And I think those three aspects that I was mentioning earlier, this opportunity moment, this reactive moment, and the framing moment, basically, I hope will help you maybe to better understand what's going on behind the scenes and to understand why we have a certain way of trajectory that was chosen, and while some other policy options were maybe less considered or less dominant in the discussion. And one last remark, because we're still a climate NGO, so I want to make sure that everyone is aware that we are not by no means on track to maintain or to achieve the Paris Agreement. On that map, you see all the countries in the world with and then like an assessment, like where it's available, an assessment of the policies, and you see that there's no country right now with a plan that actually is compatible with the Paris Agreement. We have a lot of countries that have either insufficient, critically insufficient, or highly insufficient plans. And this is just a small reminder for you as students and the other audience, of course, as well, to make sure that we all try to find ways to increase and to green that map a bit in the years ahead. All right. That's it from my side. I'm very much looking forward to your questions, and I will stop sharing the screen because then I can also see someone. Thank you.
Okay, thank you so much for your talk. Does anybody have any questions for Till? In the audience? Okay, let me get the mic.
Okay. You hear me? Just testing.
I can hear you. I can't see you, but
Okay.
I can hear you.
Okay. Well, you mentioned the framing in one of your slides, and it seems to be quite an integral part of what decisions are made with regards to response to crises. So I was wondering what you can say about how this frame comes about, what influences this certain frame. Is this like a conscious choice or something that changes day by day?
Perfect. Yeah, thank you. Thank you for the question, and nice that you picked that up. So you asked how do they come about? I think framing is it is an intentional decision. It is basically if you believe that the policy options that are on the table will depend on how we discuss a certain situation, then you as an actor would always be in the interest that your option, or like that the way how we talk about it will be in your interest. So one example from the Green Party, for example, in the European Parliament is that they always highlight they don't talk about the energy crisis, but they talk about the fossil energy crisis. So they really want to make sure that you understand when you listen to their publications, and also like I also put in my title, for example, that we are currently in a crisis, but this is the crisis related to the fossil energy. And if we think about alternatives, how we could have like energy, then we can think, okay, if we had renewables, we would maybe not be in that situation. And by talking about the negative dimension of fossil energies, in that regard, it is like it helps you to frame positively about the renewable as an alternative. So it is definitely a conscious decision. It has a lot to do with how you communicate and how you publish your argument and your contributions to the debate. And then it is picked up by whatever audience you have. It can be decision makers in the room, it can be media, it can be the audience of influential newspapers. And then, of course, this dynamic is then not done by everyone consciously. So, for example, I usually talk about energy crisis, and then when I made myself aware, okay, I want to highlight the fact that it's a fossil energy crisis, then I will change it. But of course, audience not always is aware of what's going on. And that is why I wanted to share it with you, so that you also maybe see, okay, why do we frame it like this, and why don't we talk about this? So that was basically the idea behind.
Okay, so maybe a follow-up question on that. Maybe specifically for the European Union, do you know what the influence of like lobbying is on this framing, or is this something separate?
It is definitely a huge part of what's going on in Brussels. Like, I mean, I think to go in more detail, probably would bring us somewhere else when it's about lobbying in Brussels. But definitely a lot of what we are doing here, like our organization, but also other organizations, is about how do we, this basically relates to this question. So one example is that I was just giving you, right? So that you will say, okay, we discuss affordability, we discuss the supply side, but there are some actors that for example then say, okay, but we like the current material consumption is way too high, and we cannot just shift from combustion cars, for example, to electric vehicles, because the need of resources and energy will be way too high. And then sometimes you have those talks, and then the media, like basically the venues where this happens is basically either summits or like policy debates or roundtable debates. So like there's a lot of those gatherings and meetings here in Brussels that have always the objective to bring people together and to exchange arguments and to exchange views. But of course, those are basically those places where those frames develop. And lobbies are substantial, like key actors in that, but also members, also state leaders and governments. They also have their interests, so they also want to see debate going in a certain direction, and they will also pay attention how they talk about the developments.
Yeah, you have a follow. You have another question? Okay.
If I could, yeah. So you mentioned that usually in crises, the action that happens is usually reactive and not proactive. How would you incentivize parties, political parties, or the EU to become more proactive for these kinds of things? As usually the motivation to deal with issues doesn't come up until the crises actually happen. So how would you address an issue like that?
I think I mean, okay, two examples. One example would be, of course, even in crisis mode, try to call on them to be to think ahead and try, like, always be a voice in the debate, be it as an organization, be it as a public, to demand that the responses are like critically evaluated. And like another option to avoid that this happens too much is by installing independent actors in the policy-making process. So, for example, we have at the European level the European Scientific Advisory Board for Climate Change, which is a quite new body. It's a scientific body. You have also that often member states that, like in countries in the European Union or also beyond the European Union, of scientific advisory bodies that are like basically researchers or scientists getting together and developing some positions, and then they want to inform the policy-making process. So we also have this now with the European Scientific Advisory Board for Climate Change at the European level, and they just did a publication where they did this like a first evaluation of some of the measures. So of course, by having those bodies and by making sure that the decision makers, so be it either governments or be it parliamentarians in the European Parliament or be it the European Commission, by making them listen to these bodies, you can have a positive impact on this in that regard. That you basically, for example, demand from the Commission that they have to listen to the latest publications, or you have some international organizations like the International Energy Agency. They do evaluations of the measures as well, and then you bring them into the field of the policy of the interest, basically of the interest balancing act.
All right, we have time for another question. Does anybody have any questions for Till?
So, I guess you limit your discussion basically to Europe, which is of course what we have to do to do our chipping into this crisis. But the problem is really international. Is that correct? I guess you all agree on this, right? And the question is, how do we do this sort of lobbying or campaign at an international level? Because at the end of the day, CO2 problem is not recognizing any borders, right?
Yeah, thank you so much for this question. I forgot I wanted to make this message in the beginning that we'll be talking about the European Union, because that's basically my job and where I have most knowledge. But I love to talk about that because I think it actually relates also to how European Union is advancing. What we see now, I don't know to what extent you're following the debates, but we had end of last year the Clean Industry, the Inflation Reduction Act, which is basically a U.S. American policy that has the goal to to scale up in a very, very, very drastic manner clean tech industry, basically giving a lot of subsidies to producers, but also to private households, for example, to buy like electric vehicles. So like to really have like a lot of money put into the economy and to put into the society to fast forward the transition. And then Europe respond to that with a Green Deal industrial plan. So that is basically the European response to that. And what the danger that I see, and where I think where we have our battle ahead, is that we don't believe that we can just be like this great example of climate neutrality by 2050, and leaving everyone else behind. Because where I see the danger right now is, for example, that we try to get resources from other countries. So because of course you have like those critical materials that you need to build up the clean technologies, that we just get them from other countries, and then we create value added here in the European Union, and then we are like a very successful prime example of climate neutrality in some years. But as you were rightly saying, this will not solve the crisis, because emissions will be emitted elsewhere, and depending on how we go about this, we can either help others, or like we can go in partnership together, better framed like this, to actually get globally on a path, on a low carbon path. Or if we do it wrongly and are short-sighted and too much Eurocentric, we run the risk of having maybe a very great climate agenda, like climate evaluation in 2040 or like 2050, but we will not have an impact on the world at large. So really, I think the very concrete suggestion for policymakers right now is really to go in partnership, look at fair trade agreements, look at fair partnerships where you create value with the green economy in other countries, so that you provide there also an opportunity to shift away from low carbon, from fossil fuels, and go towards a green industrial and general development pathways.
Okay, thank you for answering all those questions and for your presentation. We'll be going into a short break now, and then at 1:45, the next speaker will be starting. Yeah. Thank you. Thank you for speaking.
To repeat the previous part. Oh dear. Oh, that accelerates. That's good. Yeah, you're good? Yeah. Hi, people online. I'll not repeat the previous part. Yes, this graphic, who knows this graphic on the left bottom corner? Who knows that one? No, really? Okay. It's a famous and a little bit notorious one. It comes out of the so-called 1.5 degree report of the IPCC. It was just preceding the last big update of the IPCC which was a lot of press coverage a few weeks ago. But it was the report that focused on how can we still meet the maximum 1.5 degree global mean temperature change target in this century? Can we constrain that temperature change to that target? Because that is, with the state of science that we have now, seen as a level in which the risk of kind of uncontrolled climate change is still manageable. It's not certain. There is a good chance that we can keep things under control. It's really that language that applies. And the 1.5 degree report was disturbing in the sense that up-to-date climate science showed that the Earth system is more sensitive to the warming and to the greenhouse gas emissions. And the other part of the report showed, okay, what is then, given that we have that as a target, needed to meet that? And it had these 4 graphics that show global emissions that are today at about 40 gigatons of CO2. And all graphics show there's a dramatic decline. There is an abrupt change, even if you look at the left-hand side. The suggestion is, okay, we're going to change that right away, which already says that may be difficult. What was interesting is in that graphic, the IPCC told the story that lifestyle changes, cultural factors, etc., are very important, and they had been underplayed in previous reports. So less flying, vegetarian diets, so also circular production and consumption. So those factors have been strongly underlined, for example, to show that such a scenario is not impossible. Let me use that word. Varieties in between, and then most focus was on the right-hand side, which shows that the curve is still going up on the shorter, medium term, maybe what you want to call it. And that's definitely what we're doing now. And it's even more dramatic today than what's shown there. So there is an overshoot in emissions. So you can look at the atmosphere as an amount of gas that still has a small budget left for greenhouse gas emissions to not warm up more than at 1.5 degree. And in that scenario, we're going to make an overshoot. The implication, if you then this century still want to stick to 1.5 degree, is that you need net removal of greenhouse gas emissions from the atmosphere. And that's the green part on the bottom. So that really depicts CO2 removal, could also be other gas, but mainly CO2 removal from the atmosphere. That has to start in the first half of the century, but just continues the rest of the century. One key option mentioned there, that's the abbreviation BECCS, bioenergy, carbon capture and storage, with the idea if you grow trees, something else, in a sustainable way, I may come back to that, you convert it to something, CO2 is formed, partially or completely. If you capture that and store it on the ground, mineralize it, there is a net removal of CO2 if you have, on the same surface where the tree came from, grow more trees. That is one of the key options online. It's not the only one, I will come back to that. And that is already a desperate message. Like, okay, we need to look at those technologies as well, on top of changing the energy system and the industrial production completely. Oh yeah, and just on the right, I should point that way, of course. The right top is the translation of that in the Dutch situation. So we'll use the Netherlands partly as a case to make some other points. And the Netherlands had already agreed, also on European level, to bring down emissions according to the Paris Agreement, but that was not 1.5 degree as translated here. So the update even made a dent in the straight line downwards. So that also for the Netherlands, it's clear that the carbon budget left for one country has also been significantly reduced compared to what was thought earlier. And the latest IPCC language says, okay, with what we know now, we may want to meet those targets 2040. So it's now getting a little bit uneasy on looking at the timelines and what we need to do. On top of that, because the symposium was about international developments, well, war is back in Europe, we all know that. And that had many effects. It will have many effects for a long time to come, I'm sure. but it definitely had an effect on global energy markets. And this is what happened to gas. And there is the European main, let's say, trade price. There is also the darker blue is the Asian spot market for liquid natural gas, liquefied natural gas. They both follow the same trend, so you can see the impact has been global. And it's really, really dramatic because the levels we were talking about, kind of pre-war era, they have been increased like 20-fold in the peak and even more. So when those price levels were there, we saw, for example, in the Netherlands, but it was worldwide, the problem of energy poverty suddenly becoming a major issue. We've seen major companies just shutting down business because it is completely unprofitable. If you look at the Netherlands, a very intensive chemical industry, ammonia is one of these chemicals that's produced in different locations. That became so expensive that ammonia production was shut down and imported from Algeria. So it's interesting that today we like to talk, hey, gas use has been reduced in the Netherlands. Yes, that's true. But indirectly, it is still imported and the emissions are still caused by that. But this is a major upheaval. And also the notion that energy security is a real thing. Europe in particular has thought that, okay, with those type of gas prices, we're connected to a global market. We have an energy transition in which natural gas is a transition fuel. That was for a very long time the paradigm. Germany in particular had a very strong focus on that and shut down its nuclear power plants. That's now a fact. And thought that natural gas could fill the gap in the meantime on the way to almost fully run on solar and wind. But that then became a very expensive business and also a very risky business. So countries like Russia, Iran, Qatar, Libya, Algeria have a little bit different idea about what it means to do a free market game. So that's now clear again. So energy security is back on the table as a key priority. Well, yeah, and this just confirms it. The left graphic is about Germany. The right-hand graphic shows the energy import dependency that the European Union created over the decades. So for oil, it was already very high for a long time. So we're looking above 90% of the oil in the EU is imported. And for natural gas, it steadily increased. And increase that we saw coming kind of towards 2016, 2017, the Netherlands and this region contributed to that with the shutdown of the Groningen gas field. I can assure you that the Russians follow that with great interest. I've been in Russia in those type of discussions several years ago in that period. And it was a meeting about many topics, but this was the most interesting one for our Russian friends at the time. The little dent you see down there is COVID, but the pickup of energy use is back. But the EU created that. That was even pre-COVID, pre-war, was an import bill of about 400 billion euros per year. So that was money spent outside the Union. If you translate that to the price levels that we have seen, still seeing, that's at the moment at least double. And it was for a while, it was 3- to 4-fold as much. And that is, if you have maintained those price levels, that's a guarantee for economic recession. Now, there was a response. We now lean much more on LNG, but that is structurally at least 2 times more expensive as the piped natural gas. So, concerns about that. There's another key thing, of course, in how we should look at energy use and that short timeline to cut carbon emissions short on a global scale, because we, of course, have seen historically that at the moment countries develop. So on the x-axis, Human Development Index, that's always a bit of a soft parameter, but you can use that as an indicator. And looking at CO2 emissions per capita, that the industrialized countries, so the US and Canada, are nicely there in the right top corner. Australia even surpasses that. And then Northern Western Europe are kind of relatively low in that sense. We are kind of equal in terms of on emission level and like Eastern Asia, which is a very big one, of course, including China. But there is still a major gap in where many countries and world regions are on that Human Development Index compared to the OECD countries. So there is a huge part of world population that wants to move to the right. Historically, we have increased CO2 emissions. It's slowed down a little bit. But now the trick is, of course, can we still continue that development while CO2 emissions are going down? And that is given the billions of people that are on the left side of the graphic, Sub-Saharan Africa, South Asia, as the major demographic bombs, let's say, that we see detonating at the moment. That is still a major challenge as well. So the development pathway, that's why those arrows are there, is really crucial today to consider. So the coal-fired power stations that are today will be in operation for 30 years. And so those decisions that are made for those development pathways are really critical. Well, fortunately, the IPCC, so this is really from the 6th assessment report, it's still almost warm from the printing, has shown, okay, we have this energy system today. So these are typical Schenke diagrams. I have a couple for you also. So just spoiler alert, there's one coming from the Netherlands, and also maybe I have time to show one for Europe. And this is still the situation as we have it today, causing about 40 gigatons of CO2 emissions. So with oil, coal, and gas as the bulk of that, close to 600 exajoules, 10 to the 18 joules of primary energy use. So hydro, nuclear, is kind of, that's going different directions if you want. If you hear the German story, yes, the Netherlands is discussing maybe building a few new ones. And worldwide, you also see that kind of shaky discussion there. Wind and solar, although there is a lot of development, it's today still small. And then there is also still a sizable fraction of biomass. And we'll come back to that one as well, because that has maybe a special role to play. So that's where we are now. And then there are many models, good models, integrated assessment models that can show this feasible, given technical potentials, even given economic potentials, sustainable potentials of options. So this is about, is there space? It's about solar radiation, land for biomass, hydropower, and then the technology. So these models can be run. And it is possible to say, okay, I have my carbon budget. The system has to transform in that direction. And you can calculate solutions. And that shows an obvious result, of course. And there are many of these graphics with ranges around everything, but with a very dominant role for solar. So in total, in this picture, the primary energy supply is not going up. So that also says something, given that we have developing world regions, really on a large scale, still increasing world population, although it's maybe fortunately, I should say, slowing down, that energy efficiency is number one. So that is really actually the key option not shown here, but that is a very important notion to start with. There's a little bit of fossil fuels left, partly combined with carbon capture and storage. We'll also come back to that. But solar here is really the big one. Wind, very substantial, and biomass also, that has doubled then compared to where it's now. And that could make the balance. What you see, so just on a glance, of course, not the same as pipelines and cables, but that the spaghetti in the middle, so that's I kind of call shaky diagram also spaghetti, is very different. And that is not just the colors, but it also means different infrastructure. This is large-scale electrification. And that is then important. So we can see that around us what the need is for expanding the grid capacity, but also in the end use. If you want that, that means industry, houses, and transport are going to use more electricity. That is also changes there. So all these devices there have to change. And it's also one explanation, definitely not the only one, why that energy efficiency goes up. Because in general, not always, but in general, electrified change are overall more efficient. And there's other energy carriers as well. So that's a big precondition. Now, just to emphasize a little bit how short we are on time and carbon budget, this is a graphic that comes from a striking report. I think it's really visually also very, very clear. So if you're interested in this, it's really recommended. It's from the Energy Transition Commission in the United Kingdom, the Mind the Gap report published last year, that went fully into what can we do to realize negative emissions. So that's that green part of the IPCC graphic. And yeah, doing the simple calculus, like what we now have left for 1.5 degrees, it's about 300 gigaton of CO2 emission space, if you want to call it. And we are at about 40 gigatons of emissions. So in less than 8 years, we're through with that. So that's why the talk is the 1.5 degree is out of sight, unless we go to these negative emissions. 2 degrees, a little bit more, but even 900 gigatons is quickly spent, right? That is then the resulting budget. You do see what the difference is. That was why that correction, if you want, from 2 degrees to 1.5 degrees had so much influence on, oh, how fast do we need to do it? And how fast do those emissions have to go down? What does it mean for investments, for example? And the need for negative emissions is definitely in the order of a few hundred gigaton if we're going to do it, which is also an interesting figure to imagine. Like, what do you do with a few hundred gigatons of CO2 captured? Right, so it can be in trees, and it can be in maybe new peatlands, which is good. It could be minerals. So if you think about carbonates, there are various options, and you can produce that if you do it the right way. You could also think about products, but it's a lot. Those are big figures, so interesting to consider that. And they have also listed the different options. So on the left-hand side, what they call the nature-based solution. So reforestation is a good way to realize negative emissions. More forest instead of losing forest, obviously, which is getting more challenging with climate change effects becoming more visible. If we look at European forest, the forest fire in the Pyrenees Mountains was already reported, and we're in April. So it's not easier, but it's important to consider that. The BECCS option, so ECHE, that's more technology, biomass, and carbon capture storage, already talked about that. But also the more dramatic ones, direct air capture, is also serious research and investment and demonstration. There are companies doing that. If you look at Internet, Climeworks, C-L-I-M-E Works is a company in Iceland that has an operational direct air capture unit. And there are optimists that say, well, we may be able to do that, about $100 per ton of CO2, which is not super expensive. It's not cheap either. But okay, it does take energy. So if you're going to do that on a large scale, you need more solar, more wind to do that as well. Challenging. But okay, I think you're not getting in a good mood, right? Hearing things like that. So, but I am not fundamentally pessimistic, nevertheless. I mean, the timelines are dramatic, but if we look at what we can do with that energy transition, what we today have at our disposal in terms of technologies, but also in terms of real business. I mean, this is no longer a story of subsidies and targets and obligations. I mean, I will come to a range of examples during this talk. So that's one, it's possible, it is overall affordable. But also we see, for example, looking at that energy security discussion, this is a key answer of reducing dependence on those now risky fossil fuel imports, especially from a European perspective, but it's also true for many other countries. This is the thing. What was maybe 10 years ago, renewables were looked at, okay, that is a difficult system, you make it a more unreliable energy system, you need to take all kinds of measures, is now almost turned around in terms of perception. And then there is also all kinds of co-benefits of this energy transition, like moving away from internal combustion engines has a good effect on air quality. At the moment, you have more circular production and consumption, means less heavy industry, less need for primary steel and primary plastics, for example, and it will also give less waste, which is an expensive sector, and also comes with environmental problems. And there are many more where we can see, hey, that energy transition is not just a story of a burden and something that will slow down economic development, possibly on the contrary. Now, the titles I put there are Dutch, unfortunately, so I don't know how many of you are Dutch reading or speaking, but but there is also English literature behind it. But there were very easy to read publications from with TNO modeling behind it that make those things very clear. And I will give some examples because going again at those models, and they are at this stage really at a very sophisticated level, a lot of detail, modeling the energy system with a high temporal resolution to see what is needed to balance the grid with fluctuating solar and wind, how much storage, what can you do with demand-side management. So those kind of things are there, energy infrastructure, etc. High technical detail. And if you run those models for the Netherlands, say you have to do the pathway that I talked about, 1.5 degrees, so even with the dent in there, you can even have different storylines that would make that both possible. So the storyline of adapt is, okay, we have little time. We have to work with infrastructure and stuff we have to quite an extent. We have to look at options that can deliver. And that, for example, means that carbon capture and storage is important in that scenario. So there is still an amount of fossil fuel. So the bluish, grayish is not zero in that scenario. But there is a high amount of green, and that's biomass. That's, of course, a big point, needs to be there. So we looked at national resource, we looked at imports from the Netherlands. So we may come back to that later on. But what that means at the moment you have biomass, for example, in retrofitted refineries, which is a possibility, and have carbon capture and storage there, those refineries can produce negative emissions as one of the outputs. And that means there is a little bit of emission space to compensate for a part of the fossil fuels and also some other difficult parts of the remaining greenhouse gas emissions. So that is a part of the story. There is definitely a strong increase in wind and also in solar. It's not super dominating, but it is almost a pragmatic system. And we see that there is a dent in the energy use, and then gradually it goes up because the base assumption is economy still keeps developing. You can argue about that, but then it gradually goes up again, but stays lower than today. Transform is a more dramatic change. And what happens there is that fossil fuels are really phased out. There is less biomass use. Total energy use also lower, so there is more a bigger role for energy efficiency, but also in terms of consumption. So circular economy options are playing a bigger role there, and that has an effect on primary material production. And there is an even bigger role for electrification, for example. So wind and solar are really dominating the total supply. Also geothermal is even bigger there, and both do the job. So some other differences that you get. So both meet the target. Keep that in mind. So electricity use goes up. There's at least a doubling compared to today. So you can say that's no regret, and that's true for basically any industrialized country. But it could also triple if you go to transform. The role of electricity gets bigger. But of course, as a consequence, more interventions are needed in energy infrastructure and in the final use. Hydrogen, there's a lot of talk about that. And mind you, these models have this high technical detail that I briefly talked about. They optimize what is needed in terms of storage, conversion, etc. And remarkable, but the role of hydrogen is fairly robust in both scenarios, but not dominating. So about 8 to 10% in these two storylines. You can go to extremer values if you want, but those are quite all right. So it is important, but not dominating. So especially hydrogen is produced for industry. So few demand centers where you need less investment in infrastructure, almost nothing in the built environment, because it would mean you have to distribute it everywhere. And that can also be understood if you look at the bottom-up example. If you have 1 kilowatt hour of wind power being fed to a house, and that house has a heat pump, it may be able to make about 4 kilowatt hour of low temperature heat from that 1 kilowatt hour of wind power. There's a little bit of losses in the grid, but not so much. But if you take that 1 kilowatt hour from wind power and you put it through an electrolyzer to make hydrogen, transport the hydrogen, get it in the house, you need some pressure and storage along the way. And then there is a combustion, could be a fuel cell, but it's another loss as well. So overall, you have about half a kilowatt hour of heat of that 1 kilowatt hour of electricity in the house. So it's a factor of 8 difference. So that is an explanation why hydrogen in houses is really way more expensive than electricity to houses for heating. For transport, it's a bit on the edge. So you see that electricity, other fuels, so this could be e-fuels, biofuels also, and also hydrogen sort of compete, so they are in the modeling very close. And that is what we're looking at for hydrogen. So then I've said that also. And then biomass, that's a very important one. And of course, the debate here is, can we get those amounts of biomass? The thinking is that about 300, here we're talking about petajoules, so it's open, and the Netherlands is at about 3,000 petajoules, 3 exajoules, so I should say that correctly. So you see that the role of biomass with 1,000 to about 600 in both scenarios is very large. And that's partly because the Netherlands has a huge energy demand for aviation and for international shipping, because with its transport hub role, there's big refineries also here. So the assumption is that that still continues. You can also argue about that. So part of that comes from national supplies, about 1/3. That is deemed possible. There could be raw material or intermediate product imports, for example, from Eastern Europe is the thinking. And it could also be biofuel import, for example, from countries like Brazil. And they go especially to industry as feedstock. So this is where the petrochemical industry is displaced by a bio-based industry. And that's also where these CCS options pop up. And the other big one is indeed that international transport sector, because that's where those liquid fuels are very hard to replace. I'm not saying impossible, but in the timelines we're talking about, very hard to displace. In Transform, the picture is not very different, it's just smaller. And that's because electricity is overall playing a bigger role in these end-use sectors. What you can also already imagine, thinking about spaghetti, that the ADAPT, where we work with more of the existing infrastructure, that, for example, part of the refining capacity, part of the distribution capacity of those fuels can still be used. So that is something to consider, given that we have little time. I'm agnostic about both scenarios, but so here we have the role. This is only for ADAPT because we allowed for CCS, and that's a sizable amount because the amount of CO2 that is expected to be captured is about 50 megatons, so that's about a quarter of the emissions that we have today. And that should then continue also, of course, after 2050. So there's also a question of where do we put the infrastructure for that? The North Sea can harbor a lot, but it's also a logistic challenge. Now, this is, that's not a very interesting graphic, right? But it's the most important graphic, I thought. Because one thing that has a lot of detail in these models is cost. Investments, operational cost, the cost for infrastructure are there, and also the investments needed for the changes in the end use. This is always difficult, because what is now the cost of an energy system? At the moment, you talk about the change of going from a current gasoline car to an electric car. Do you take only the cost difference? Do you take the whole car, etc.? So definitions for this parameter are always hard, but what's least good, it's done for all bars, it's done in the same way, so you can compare them. Now, what you can do is run the model without a target to say, okay, what happens then? And mind you, these results were made with fossil fuel prices and projections for the long term that were there pre-war Ukraine. So on a relatively low level. But what happens at the moment, you have no target. There is a lot of things happening autonomously. So there is more wind, there's more efficiency, so that's attractive, but not as fast. So the share of fossil is higher than in adaptive transform. And with the projections that the International Energy Agency always delivers for this, and they are today much higher, the cost of the energy system go up. So no target, no climate target, enforcing that means that the energy system is going to become more expensive. If we go to ADAPT, where the 2030 was taken as the 100% level, so that's the measure to which the other ones are compared, then we see that they stay lower, although over time they also go up. There's also share of fossil fuels there, keep that in mind. And we said we would work with more conventional technologies, and that is maybe on the short term more attractive. On the longer term, there is less improvement potential. So if you go then to transform, where the changes were more dramatic, so the starting level is a bit more expensive, so higher upfront investments, for example, and maybe also partly less mature technologies, but over time, more efficiency increase, less demand, and also more learning potential in those more advanced technologies. So that means that the cost of that particular scenario could end up lowest. Mind you, the reference there was pre-war Ukraine, so if you would make the grayish bars now, they would be a lot higher. Inside this, that future energy system can be cheaper than the energy system we have today, or the energy system we would be stuck with at the moment we don't push those changes. It is more competitive. It is economically sound, right? And that's still a message you have to hammer in many, many places. Yes, this is combined with a huge amount of investment. So it's hundreds of billions of euros. But a lot of investment is not the same as that the thing is expensive, because the reference means buying a lot of these imported, expensive fossil fuels. That's expensive, and it is not going to give you the change system. So that's a key notion, that we are looking at the possibility to do this economically sound. But there are massive preconditions, especially given that we're talking about less than 3 decades. Precondition number 1, all options need to contribute. So don't skip options. And you could see that already a little bit in the scenarios, that there's a whole portfolio of options in the end use, in the supply. You could also see that in that subtle role of hydrogen. It is not the energy carrier, it plays a role to balance things. The second key factor, I've not talked about that a lot yet, is innovation and cost reduction of the different technologies and systems. So I will come back to that, but with wind and solar, we had spectacular results over the decades. The decades will come back. And it is really a key assumption in those scenarios that that will continue with a vengeance, not only for solar and wind, but for all the other technologies that are partly less mature. So that's a critical one. And the last one, maybe the most critical one. It's nice to say that, optimal planning and deployment. It means that that entire process requires perfect implementation. Things need to be done there on time. No barriers. Licensing is on time. Legal frameworks are there on time. The energy infrastructure is there on time. The investments in innovation are there on time. Citizens support it on time. Is an interesting one. Or companies want to invest on time. So that list of optimal planning and deployment may be one of the most complicated one, despite the real award that can be won. I can say that really with, in good Dutch English, dry eyes, that this is a real possibility. We can develop that future energy system with our sustainability targets in a profitable way. How much time do I still have? Right. So I'm especially then going to show what I'm not going to talk about. I will give you flavor of the type of things that you have to keep in mind. If you look at industry, that's an area where many options come together. So all these energy carriers, but also completely new factories. And also circular economy design. So this is partly about reducing the need for primary steel, primary plastics, etc. And if we look at the technical possibilities of all these options, it's enough. So that confirmed by the scenarios. But to mix what is optimal for all these different industries over time, that's a super complicated question. Because you can look at the top, there's a factory with a process and a value chain. Okay, there's already many options. They are often embedded in industrial clusters. Look at the Rotterdam Harbor area, for example. 40 kilometers of heavy industry that is fully interconnected. So when you're going to change there something, other things will be influenced as well. So how do you do that? And it is interconnected, increasingly interconnected, with the total energy system. That will have fluctuating electricity supplies, may have variable biomass imports, may get, at some moment, CO2 pipelines. So how do you connect it? Massive challenge. And then, in the innovation part, and that's where the good news is, but also where it gets complicated, it's not only biomass CCS, or only electrified process, or only hydrogen. It is really about process technologies that combine these options in a very clever way. And that's where a lot of the efficiency benefits are. Take one example, a simple one, but an important one. If you have a big electrolyzer, which are built today for industrial centers, electricity in, and makes hydrogen, but also makes oxygen. That's often forgotten, but oxygen is a very valuable commodity. If you have pure oxygen and a biomass gasifier, it runs optimally with pure oxygen. So you feed it there. At the moment you have a biomass gasifier with pure oxygen, it produces very good syngas that you can use for further chemistry. And it is very easy to capture a part of the CO2 further down. You have biogenic CO2, so that's the sustainable CO2, if you want, or renewable CO2 from biomass. And that can be used for further chemistry with addition of green hydrogen to make simple chemicals. So that is an example of a type of integration that may also give a lot of flexibility for these future chemical and fuel plants. So that's what you have to think about. Circularity, this is a European graphic for what we partly produce today in terms of plastics, and there is some recycling, and there is an amount of mechanical recycling today, that's about 30%, can be increased, but especially chemical recycling, so going back to the monomers of the plastic, maybe sometimes more dramatic steps with plasma grading even, so there's a lot of high tech down there. The thinking is that most of the carbon can be kept in the loop, one way or the other. And that means, of course, that you need far less virgin monomer production for these plastics. And looking at electricity in industry, that's also a spectacular field of innovation, from low-tech stuff that's important today, e-boilers. So you throw out the gas boiler, put in an e-boiler, and they can also offer flexible demand, so important today, to stuff that puts electricity in combination with a good catalyst. The good catalyst is then the magic, of course, with air and water, you make ammonia. That's solid-state catalysis. So it's something that's possible. It will make ammonia production much more simple. It's low TRL, low technology readiness level, so it's one of these processes that has a big promise to disconnect ammonia production from natural gas. But it still needs to go to development stage. And here is graphics. Yeah, I'm going to say that you're going to get a presentation And every slide has references, so if you're really interested, you can look it up. But it shows steel, the conversion over time to 2050, almost the same cost levels. So steel production with green hydrogen does not have to be more expensive than steel production today. And for the plastics, the monomer production goes down, as I just described. And there's first an increase in cost, and then you go in the learning curve, and we are almost in the same cost range as plastics today. So those are underpinnings of the statements I had on the total system. Many more examples. Refining will collapse. Maybe ammonia goes up as a carrier. So we have the type of stuff. So for Europe, similar stories. But there is really great stuff from a PhD that graduated cum laude here in this university on the European energy system. I can really recommend that work. Eric Blanco. North Sea, very important. So we may be looking at 400 gigawatts of wind capacity on the North Sea. That may require a whole artificial archipelago. The first islands are being planned and built, also by Denmark, for example. Belgium has a plan. So we need that. And it is still a bit of a question how much of this energy will come onshore via electricity or via hydrogen. So we need that much better. We need spatial planning, big thing there. And infrastructure. And biomass. Yeah, I've talked about biomass. This is a matter of agriculture, forestry, and using marginal degraded lands. And that's a big debate. I'm a big proponent of biomass because I think it's at the nexus of better agriculture, better farming, climate adaptation, restoring and revitalizing degraded lands. And as a byproduct, you get the biomass. But there are also people very nervous about that. So this is especially a societal debate that we still need to crack soon to make those contributions of biomass a reality. Difficult topic. And energy may come from further away. So we have real perspectives that competitive green hydrogen can arrive in our sea harbors maybe 10 years from now. Maybe from the Middle East, maybe from Patagonia, or Namibia. The alliances are there. Germany is also going in that big time. And this is the graphic in the left bottom is actually an old one from the Desertec Consortium. It's already 20 years old, I think. But they were visionary because they talked about the super grid from North Africa to Europe, including hydrogen pipelines. And many of these little dots, solar power centers and big wind farms are reality today. And I'm going to Morocco in the summer for a conference that's exactly about that. Morocco has wind and solar and hydropower, so they can balance the whole thing. And they see a real possibility for economic development. Great story. Learning curves. Costs go down of solar, of wind, of batteries. But we need much more. And the point is that this is fantastic achievements for solar, wind, and batteries. Electric cars are today already competitive. But it took decades to do that. And we don't have decades. So what I am just crudely going to say is that this is one of the key things we really need to put pressure on. How can we learn from what we have done in the past and do it faster in the future? And the overall statement is that can be done. At the moment, we really understand how these different phases of innovation, of scale-up, of market maturity. And it's not only technology, it's also about financial conditions. It's about innovation systems of research, companies, supporting companies, networks, exchange of information, governance factors come together. Some countries have been really good at that. Denmark, for example, is a clean tech champion in Europe, and they really understand this game. The Netherlands is not good at this game because we have been very good in creating hiccups, but it can be done better. So this is then also about when do we do what? Innovation, science, knowledge. And I had examples, but I'm not going to talk about it. This is work from Marco Hackett, who's now director of the Environment Agency. We worked together for a long time in the Copernicus Institute. How long it took in the past, often long, but sometimes not. It's interesting to learn from the stories where that went fast, to go through these formative phases. And you have to understand what is done over time in the success story. So this is studied in detail for wind, from the prototypes to the market saturation, where wind is going now. It's fully mature, fully competitive, no subsidies needed. It is an industry that is accelerating itself. But how this was done is a very important story. And we also need to do it for those heavy industry processes, for example. It's a complex system in the future, and I will finish with this slide. And it is definitely not only about technology. This is even an engineering view. Like many people in the energy field would still like to start from technology. They say, okay, I need money and subsidies to make it profitable. Make a target, please, government, and we'll tell people it's okay to do it. And that's a recipe for disaster, especially in our complex society. So you may want to put the social part in the middle, or the regulatory part even, because we have major bottlenecks there. At least it's something you have to look at in an integrated way. And it is definitely not only a story of natural scientists and engineers, but just as much for legal people, social scientists, and the like. I will stop here.
Okay, thank you for your presentation. Are there any questions for Professor Hunter? I'm going to pass the boxes.
Oh, yeah.
There are glasses in the crowd now, guys.
Okay, hello. Yeah, I had a question about the transform scenario that you mentioned in the model studies, and I was quite surprised to see that in the long run it might be cheaper than reusing some of the infrastructure that we already have. And I was wondering if this specific scenario does include some form of reusing the current infrastructure that we have, or is it exclude that completely?
No, it's not. If you look at the details, it's definitely not science fiction. For example, one thing done for hydrogen, for example, and that is something you can see happening today, so it's not study work, is reusing a part of the natural gas grid for hydrogen. So that's a simple example. And of course, whatever we have in terms of the electricity network stays. It just needs to be adjusted, but needs to be strengthened. So, no, it is not a matter of doing things completely different on purpose, but it's just that the changes in the energy infrastructure and the end use are more dramatic in the transform scenario than in the adapt. It's especially visible in, for example, less liquid fuels, which look at the gasoline stations and all that. If you, even with the ambitious targets that we have to not sell any internal combustion engines after 2030, 2035 maybe, to phase out that entire fleet before 2050 will be a draconic thing. That will really be hard. So yeah, how realistic is that? And should you maybe maintain a part of your liquid fuel infrastructure that's then fed by carbon neutral fuels?
Yeah, and I think that argument is also often made with the current, like, even in the power sector with fossil plants that we have right now. You mentioned retrofitting of current power plants into like biomass. Is it something that's incorporated in there as well? Is that
that's for sure.
used?
That was in the ADAPT. The combination of biomass CCS is a very important one. And that is not only because you can use some existing capacity, like that could indeed be the coal-fired power stations with biomass and CCS, and the refineries, but also because the negative emission component can compensate a part of the positive emissions. And that means that some parts of the fossil energy infrastructure can still operate under that target. If that is also fundamental debate on that, people say, yeah, okay, you just keep digging out more fossil fuels from the ground, and you're going to use a part of the CO2 storage capacity that you may need on the longer term. So there is also principal debate about that. Okay. All right.
Are there any other questions? Oh, yeah.
Don't throw too hard.
Yes, so I have a question about the plastic recycling that you mentioned.
Yeah.
So currently there are a lot of different types of plastic. Are you confident that in the future people and companies will cooperate to actually recycle this amount of plastic?
Yeah, super good question. Because it's easy to talk about, we're going to get these very high recycling rates, but indeed, there's a few key preconditions to do that. One is you need consumers to support that. So this is where societal support is a key factor. Are people really willing to bring back their products? So it could be what's the term for statiegeld? Right? What's statiegeld in English? Are they willing to accept it or not? Are they disciplined to kind of keep the quality of the plastic waste high? That's one. And the other one is indeed in manufacturing and companies using the packaging, for example. That one thing that makes life a lot easier is to go to far less plastic types and also different plastic types. That is, there's options for that, but if you take PEF, it is the bio-based equivalent of PET, so the PET bottles that we all know. You can make that bio-based. It's chemically a little bit different. It's even better for packing Coca-Cola, so that's why they're using it. But it's a beautiful plastic because it can be used in a very strong container that could easily be recycled in a classic way, like 10, 20 times. So that's the statiegeld system. And when the bottle is considered worn out, it is separately collected, and it can easily be transferred again to the original monomers. So there's two monomers in that plastic. And that means there is the virgin material is back, and you can then do a chemical process again to make virgin plastic. So the footprint of that plastic, including the recycling of the consumer, is like 97% less compared to what we have today. So that's the type of changes you need. And then what is needed as a virgin input is bio-based. But okay, what I'm listing now is a lot of changes.
Yeah.
And so that's the story why it is also complicated. But it's well possible, and it's probably also going to be cheaper to do your packaging that way.
Oh, thank you.
Are there any more questions for Professor? One more? Okay, that'll be the final question. Can you pass the box mic? Back there.
Yeah. All the time that road.
Yeah, all the way in the beginning, you mentioned transition pathways into renewables across the globe, and that it's a big challenge for developing countries to find a correct pathway or a helpful pathway for this. Sometimes an argument is made in Western countries that, oh, we're too small, we don't impact anything. Do you think that being more ambitious with the investments that we make in, for instance, the Netherlands, could positively influence the transition pathway in maybe more developing countries who may not have the investment qualities that we have?
Yeah, no, a top question, really, really good. I'm happy you asked it. I did think the latter, what you say, is important, that these complex innovation trajectories, it's not only the R&D, but it's also the scale-up, the implementation, making it reliable, etc., and building an industry that can also deliver that. That is a complex, and in terms of investments, an expensive process. And I think it is unrealistic to say, okay, let's expect from Sub-Saharan Africa that they will do that for all their future industries. So this is indeed where I think the OECD countries can play a fundamentally important role by prioritizing that innovation. That's why I listed, it's a few words, but the expenditures that we today do on the research, development, demonstration, and deployment, so the R with 3 Ds, is still not enough. And we know that this is one of the most profitable parts, because any billion that's put in that will have a rate of return that is way, way higher. So that's something that needs to be understood, and something that Western countries can prioritize. But there is also a lot of options that can be done almost right away in the, for example, least developed countries as well. I'm just back from Mozambique, which was still a program that we run here from the University of Groningen. So it was a 5-6 year collaboration, mainly focusing on energy education. So there was a master program and PhDs and etc. But part of the research that is now in the final stage is focusing on microgrids. And Mozambique is a country where still 2/3 of the population does not have electricity. And the base model is, okay, somewhere there's going to be a coal-fired power station, and Mozambique has coal. They also have gas. And the grid is gradually expanded. And if you're lucky in the right place, the grid may come sooner. And if you're unlucky, the grid comes later. That is the classic model. And the microgrids were always seen as, okay, if you really have no chance that the central grid comes, you do that, but it's more expensive. And that is really uneasy for people with the lowest incomes to have expensive electricity. But the situation today, and the situation that we are likely to have 10 years from now, so in a short time frame, actually make microgrids cheaper than coal-fired power stations with the grid. Because the solar cells are now so efficient, and the batteries are getting so cheap, and the combination with wind, or sometimes biomass, or microhydro can be done so cleverly, that we can start to reverse the story. Microgrids can be stimulated everywhere. It is something that can largely be operated by the local people. And at the moment the grid comes, you can feed to the grid, and cheaper than by the coal-fired power station. Now this is something 2 PhDs from Mozambique are finalizing. One is looking at techno-economics, and the other one is looking at implementation. And I hope they will defend next year. But this is, we already said, this story needs to be told in different channels. because this is a real perspective for electrification in many developing countries. Now, that's a fundamental change compared to what we have done decades ago. And there are more of those examples. The leapfrogging notion, so skip what we have done and go directly to the clever solutions. There is more options for that. So at the moment, industries still need to be built. Okay, the blueprints for this sustainable industry are visible. At the moment, you're looking at transport. Well, why expand your fleet with gasoline and diesel if you know electric cars are going to be cheaper and you can make electricity from solar anywhere? So it's simple reasoning, but it is a reasoning I think that can make a fundamental difference and make those pathways avoiding the hill also possible. But it needs to be discussed now. The notion in many places still needs to be strongly emphasized, and that's why the study work is really, really important.
Okay, thank you. Let's give a last round of applause to Dr. Well, that was our final presentation. I would like to invite all of you to join us after for a bottle with snacks and more of the drinks in the hallway, as well as possibility to talk to the speakers individually, as well as just discuss this with each other. And I would like to thank you guys for attending, as well as the online audience for attending. Yeah, thank you guys for coming to the first. Oh, don't remember to turn back in the wristbands before you leave the building. But other than that, I hope you enjoyed, and thank you so much for coming.
Ik vond ook weer zo wat, maar dan ben ik.
Ja, ik had er nog zo goed klaarstaan.